Hello there! In this tutorial we are going to be making this game. However, the game itself isn't really the point of the video. Instead, it is more of a vehicle to explore Pygame. Essentially, this is an introduction to all the major components of Pygame that you need to start making games in Python. And by the end of it, you should have all the tools to approach any 2D game, starting from text adventures and Pong, going all the way to the first generation of Doom and Wolfenstein games. And I do plan to make more advanced games in Pygame, so get subscribed if you don't want to miss those. And really quickly before I start, you should know some Python already. It doesn't have to be much, but I do assume that you know how to use functions and simple classes. So nothing fancy, but the basics of Python. And if you want to code along, you can find all the assets in the description. So I hope you enjoy. Alrighty, so before we get into any actual code, let's first talk about how video games work on a general level. That is really going to help us understand what Pygame does and how it actually works. So how do video games work? And I think the best way to think about that is to start with movies, because that is the technology video games leaped off from. Essentially, a movie is really just a ton of images playing really fast after each other. So for example, here's a movie, and all I have to do is to slow it down and you can see individual images. Although for movies, these are usually called frames, but it's the same thing. And most of the time, a movie has 24 frames per second. So you see 24 images per second, and your eye perceives this as a moving image, at least in most situations. And if you do this long enough, you eventually have a movie that lasts about an hour and a half. And that's essentially it. The only real difference between different kinds of movies is how each individual image is being made. And there are basically 3 different ways to approach this. Number 1, you could get a camera and just point it at something and record it. Number 2, you could draw an image, or number 3, you could use a computer to create a 3D image. And each of these approaches would give you a very different look of your movie. But at the end of the day, all we're doing is creating lots of individual images and playing them really fast after each other. And that's literally it. So with that, we have movies. And video games are quite similar to that. And in the most basic sense, a video game basically works like a movie. That you have lots of individual images being played really fast after each other. But obviously there need to be a couple of differences to really make all of this work. Number 1, and I guess the most important one, is that on a video game, each individual image isn't set in stone. Instead, it's dynamic, meaning that each individual image is created on the fly and placed dynamically depending on what the game needs. So for example, is the enemy in a certain position? Or did the player press a certain kind of button to move in a certain direction? And then each individual frame is being updated automatically. Whereas for a movie, each individual image is basically always the same. So this already makes video games different, that you have dynamic content. And that already brings us to the second point, that for video games, we are checking player input. Which means that at the beginning of each image that we are drawing, we are first checking the input from the player. So we are checking if the player presses a button on the keyboard or moves the mouse or says something into a microphone. Lots of different things that we could be checking. And then we're using that information to place something dynamically on the screen. And well, once we have accounted for those 2 differences, we basically have a video game. So let's go through how a video game works on a conceptual level. We always start by taking the player input, and this is usually called an event loop. So each kind of event could be a different kind of thing a player does. It could also be something else, for example, a timer running out. But essentially, we are taking all the necessary inputs we need to draw the current image. And once we have all that information, we are actually placing all the relevant parts on the screen. So we are placing the player in a certain position, we are placing all the enemies, we are drawing the health indicator, the coin indicator, whatever we really need. And well, once we have all of that, we have one finished frame. So this is one image the player is going to see. Now, once this process is finished, we are getting rid of the entire image again and starting this process from scratch. And we are doing this multiple times per second, usually about 30 to 60 times, depending on how fast your computer is. Now that is really it. And this applies both to 2D and 3D games. So it doesn't really matter if you have a 2D image or a 3D object to generate each individual frame. At the end of the day, you are just putting different elements together and displaying them to the player. So with that, let's talk about how Pygame comes into this. And well, Pygame has a couple of key functionalities that we can use to make a game. And it doesn't necessarily have to be a game. We could also make a movie in Pygame, or we could display some graphs. This would also be possible. So what does Pygame actually do? In the most basic sense, Pygame gives you a really good way to display images. And this might be relevant if you just started with Python development. You might have realized that drawing anything on the screen is actually really hard. And most of the time, you just work with a console where you can see text. But displaying actual images and animations is not that easy. And this is the first thing that Pygame is really good at. That it helps us create a window and it helps us display images. Something that is, well, important for video games. And along with that, Pygame can also play sounds. This goes along with that quite well. Now, the second point Pygame can do well is to look for player inputs. So Pygame can help you get the mouse position or get keyboard inputs or even get gamepad input. Lots of different things that it can do. And again, in standard Python, you have the input method, but this one stops the entire code if you want to get input, which would break any kind of game. So this would be the second important part of Pygame, that we can get actual player input. And those are the two really important parts that Pygame helps us with. But there are a couple more that are general helpful things for a video game. For example, Pygame is really good to help us with collision detection, or Pygame can help us create text and timers. Lots of things that are important for a video game, but these are things you could also do in standard code. But Pygame has lots of ways to make it easier. When it comes down to it, Pygame is a very simple module. Now, there's one important thing I do want to address. That if you want to make really sophisticated games, let's say a Dark Souls or an Assassin's Creed, then you would not use something like Pygame, because it doesn't really give you too many tools for this kind of thing. Instead, you would use a proper game engine. And this would be something like Unreal, Unity, Godot, and there are quite a few more. And the game engine has a lot of additional tools that make game development significantly easier. For example, there's gravity detection, there's support for 3D objects, there's lots of inbuilt stuff that makes game development very easy. And along with that, there's also a graphical user interface that allows you to place elements on the screen and you see the game as you develop it. And Pygame doesn't have any of that. It's, well, not really designed for that sort of purpose. So just keep that in mind. Now, this already brings us to the first important point. Why would you want to use Pygame over something like Unreal or Unity? And this is actually bringing us to one of the important parts of Pygame. That most of the time, Pygame isn't used for actual game development, at least for games that you want to publish. Instead, Pygame is incredibly good to learn how to code and to create systems yourself. So if you only ever use a proper game engine and you have all the systems in place for you, you don't really learn good programming. Instead, you learn to rely on external tools that somebody else provides for you. But if you develop all of this in Pygame yourself, you become a much better programmer. And later on, if you have more experience in programming, you can very easily switch to other engines and actually make professional games. But to get started, working in Pygame is really useful because you learn very good practices and become a much better programmer. So now let's actually get started in Pygame. And before we can start with Pygame, we first have to install it, because Pygame does not come with Python automatically. But installing it is super easy. All you have to do is either go to the terminal or the PowerShell and type pip install Pygame. And then you should be seeing a short animation, and after that, you should get the message that the module was installed successfully. So with that, let's actually get started by creating a window in Pygame. So here I have an entirely empty sheet of code. And the first thing I want to do is to import Pygame. And at this stage, I would already recommend to run the code. Here we can see we have Pygame version 2.0.0. You can see our Python version. And then you have a hello from the Pygame community and a link where you can contribute. So if you can see this message, you have installed Pygame successfully. If at this stage you get some kind of error message, you probably didn't install Pygame successfully. So check that stage. So now we have Pygame. How can we actually use it? And well, the first line we need is pygame.init. And don't forget to call it. That's really important. And pygame.init is incredibly important and absolutely necessary to run before any other Pygame code. So pygame.init essentially starts Pygame and initiates all the subparts of Pygame that you need to make a game. For example, this init helps us render images and play sounds and stuff like that, basically. And while it does lots of complicated stuff, you don't really have to worry about this at all. All you really have to do is to call it in the first place, but once you have called it, it's basically good to go. Think of it like starting the engine of a car. That when you actually do that, lots of really complicated stuff happens, but for you as a driver, well, you turn around the keys and that's basically it. That's essentially the same principle here. Now on the next line, we have to create what is called a display surface. And a display surface is basically the window the player is going to see in the end. And this we have to store in a variable that is usually called screen. And to create a display surface, we need pygame.display.setMode. And into this set mode, we have to place at the very least one argument. And this has to be a tuple. And this one should contain the width and the height of our game window. So essentially later on, when we create our window, the width is going to be this part and the height is going to be this part. So, well, that's all we really need. And in this case, I want to go with a width of 800 pixels and a height of 400 pixels. And now, once we have that, we can actually run the code and let's see what happens. And there you could see a window for just about one frame. And this is the intended behavior for now. So if you get the same result, you have done everything correct. And let me explain why this is happening. What happens right now is that we are importing Pygame, we are initializing Pygame, and we are creating a display surface. But after that is done, our code ends and our computer stops running this Python code. And as a consequence of the code ending, this display surface also disappears. So we are seeing it for a second because Pygame is starting to run it, but then closes it basically immediately afterwards. And this is why we only see it for a second or so. And well, the solution to that is that we need to figure out some kind of way to keep our code running forever. And well, for that, all we really need is a while true loop. So this while true loop is going to run forever, for the simple reason that this condition in here is never going to be false, and we have to break the while loop from the inside. So basically our entire game is going to run inside of this while true loop. And in here, we are going to draw all our elements and also update everything. So this is all going to happen inside of a while loop. And there is one important line we have to add in here as well. And that is pygame.display.update. And all that one is really doing is it updates this display surface. So that anything we have drawn inside of this while loop, we actually want to display to the player. So we have to take it and actually put it on the display surface. And this is what this line here is for. So don't forget this one either. But again, just like with pygame.init, you only really have to call it and then you don't really have to think about it that much more. So, all right. Now we could be running this code now and we would get a window that would stay open forever. However, please do not call the code right now because you wouldn't be able to close it by itself. For the simple reason that right now we do not check for any kind of player input. And one type of player input would be to close the window, so keep that in mind as well. That if you didn't check specifically for closing the game, well, the player wouldn't be able to close the game. So let's add that one first. And this again happens in the while true loop. And really what we want to do here is to check for all the possible types of player input. And this is called an event loop. And more practically, this is just a for loop. We are looking at all the possible types of player input and see if one of them is happening right now. So what we want to do is for event, so all the possible events. And to get the events, we use pygame.event.get. So this method here would get us all the events, and this part here just loops through all of them. That's really all that's happening here. And for now, all we want to check is if the event type we're looking for is equal to pygame.quit. So this pygame.quit here is a constant that is synonymous with the X button of the window. So if the type of the event is equal to pygame.quit, we are indicating we want to close the window. And if that is the case, we want to do pygame.quit. And let me add a proper double colon and indent everything. So now this is working. And well, now if we run the code, this should be working much better. And now you can see the actual window, and I can also close it. So let me close it. And we're getting an error message that we are getting the error. You can see it right here, that we have a Pygame error, video system is not initialized. And let me explain what's going wrong here. Whenever we call pygame.quit, we are basically doing the opposite to pygame.init. So these two are essentially polar opposites. That pygame.init initializes all of Pygame, and pygame.quit uninitializes everything. So once we're running this code, we can't display anything anymore. So we couldn't, for example, run this method here because Pygame needs to be initialized for this to be possible. And basically what happens here is that we are calling this method, and then we continue down our code, and then Python encounters this line and it can't run it, so it throws an error. So the problem here is that we are closing Pygame, but we still keep this while loop open, and this is causing the problem. So really what we have to do is to end this while true loop on the spot. And well, you could call something like a break statement in here, but the most secure way to close Pygame is to use the sys module. And the sys module is something inbuilt into Python, and it gives you access to different system commands. One of these commands is to close any kind of code you have open entirely, which is exactly what we want. So, well, I want to import another module, and I only want to import one specific part from it. So I use from sys import exit. And this exit method closes any kind of code once you call it. So, well, I just want to do that. So I call exit, and once we have called this exit here, this while true loop will also be gone. So then we are not calling this pygame.update anymore, and our code is just going to end. So now let's try all of this again. So I can still see the window. If I close it now, our code just finishes and we don't get an error message. So this is working pretty well. Now with that, we have a basic setup for our game. Although there are two more things I would like to add. One is very simple, the other is slightly more complex. So let's start with the more simple one. And well, all I want to do is to give our game a title. Because if you check right now, we just call it pygame.window. So you can see it up here in the title. We have pygame.window, which, well, doesn't sound particularly good. And we can update this title. Let's say do it right up here. All we have to do is call pygame.display.setCaption. And in here, you have to pass in a string with the name of the game. In my case, I just called it runner. And now if you run it again, you can see runner in the top left. Now you could also change the icon, but in my case, I don't really care so much. But okay, this is a pretty good start. Now for the next part, we have to talk about something really important, and that is the frame rate, or how fast our game is going to run. And this is something really important to keep in mind. So let me illustrate. In a movie, the speed is always the same, usually 24 frames per second, and this stays constant. But for a video game, the frame rate can fluctuate quite a bit. So for example, if you try to run a modern game on a computer from 25 years ago, you will probably only get 1 to 2 frames, even at the best computer from that time. And this would basically make it impossible to play that game. But there's also the other side, that if you have a modern computer, your computer might be able to run the game at something like 1,000 or 2,000 frames per second. And if the game wasn't optimized to handle these kind of frame rate differences, the game might run incredibly fast. And this might be a problem because our animation speed depends on how fast we are updating the game. So think of it like this. We have a main player character, and let's say we are moving him 10 pixels to the right on every single frame. Now, if you're doing this with 1 frame per second, you're moving him by 10 pixels every second. Now, if you're doing this with 100 frames per second, you're moving him 1,000 pixels per second. So you have a massive difference in speed. And this is something we have to be able to address, because you want your game to run consistently on basically any platform, at least within reason. And in our case, we just want to keep the frame rate constant. So we don't want our game to run too fast, and we also don't want to run it too slow. Ideally, we would like to run our game at 60 frames per second constantly. So we have to create a ceiling and a floor for our frame rate. And well, creating the ceiling is very easy, but creating the floor is much more difficult. For the simple reason that you can just tell the computer not to run the game faster than a certain speed. And if your computer can run a game at 100 frames per second, you could just tell it to run slower. That shouldn't really be a problem. However, if your computer is too slow to run the game, then well, you couldn't magically tell it to run faster and be more capable. So to account for the minimum frame rate, you just have to be a good video game developer and ensure that there's never too much on the screen at the same time, for example. Something that video game developers are very much concerned with. But setting the maximum frame rate is very easy to do. So let's actually do that. So here I'm back in Pygame. And what I want to do is to create a clock object, because the clock object helps us with time, and this also helps us with, well, controlling the frame rate. And this you usually put in a separate variable that I have called clock. And to create a clock object, we need pygame.time.clock. And make sure that the C in clock is capitalized. That is really important. And now this is going to give us a clock object. Now by itself, it doesn't really do anything. But when we call it in our while loop, we can call clock.tick. And in here, you can add an integer, in my case 60. And this 60 is telling Pygame that this while true loop should not run faster than 60 times per second, or about one while loop for every 17 milliseconds. And that way our game is not going to run too fast. I will illustrate later on in this tutorial how this is actually making a difference for the animation. But alright, so with that we have set a maximum frame rate. Now the minimum frame rate we can't set with one line of code. We just have to make sure our game doesn't become too complex. Now that being said, we are only going to create basic 2D games in Pygame. And those are basically never going to run into problems for even reasonably modern computers. So we don't really have to worry about a minimum frame rate. But it is something to keep in mind if you want to make more sophisticated games. But alright, so with all of that, we finally have our basic setup for our window. So obviously this still isn't great because we are not displaying anything. So let's actually start working on that, and let's put some basic images on our display surface. So how can we actually draw anything in Pygame? And well, to draw any kind of image, we need one important concept, and that is called a surface. And there are two different kinds of surfaces in Pygame. And the one we have already seen was the display surface. So a surface can just be the main window the player can see. But there's another kind of surface that we are going to use much more. So let me explain. If you want to display anything in Pygame, you essentially always put it on some kind of surface. What the player is going to see at the end is anything that was put on the display surface. So this is the actual window that we are going to display. But to display anything on this display surface, we need regular surfaces. And a regular surface, or just a surface, is basically just an image. And this image can be different kind of things. It could, for example, be an image you have imported. It could just be a plain color, or it could be some kind of text. These are basically the three different kinds of possibilities. And then you could place a surface with some content on the display surface. And that way you would actually display the regular surface. I think the best way to understand this is like this. Imagine you want to create a really big poster and present it to people. The actual canvas you are putting stuff on is the display surface. So this is what you are going to present at the end. But by itself, just having a canvas doesn't really help you all that much. So instead, you have to place individual post-it notes and pictures on this display surface. And each individual post-it note and image is going to be a regular surface. And if you place enough surfaces on the display surface, at the end you are going to have something that hopefully looks quite nice. So that really is all the difference here that we have to worry about. But just to mention it, we can only have one display surface, and the display surface is always shown. So we can basically never hide it. However, for regular surfaces, we can have as many as we want. There's no limitation to it. However, a regular surface is only displayed if we actually put it on the display surface. So you could have created 1,000 surfaces, unless they are specifically attached to the display surface, they will not be visible. So, alright, that was again quite a bit of theory. So let's actually get into our code and let's create a basic surface. And for this section, I want to create 3 different kinds of surfaces. One with a plain color, one with an image that we imported, and one with text. And they all work by creating first a surface and then placing the surface on the display surface. Let's start with the simplest one, to just create a surface with a plain color. Here I'm back in my code and I want to create a new variable. And let's just call this test surface. So we are going to play around with this one, and then later on we are going to delete it to replace it with something more proper. And to just create a plain surface, we need pygame.surface. And here again, make sure that this S is capitalized. Otherwise, it is not going to work. And this surface is going to need a tuple with the width and the height. So in here, we want to get width and height. And this is very similar compared to what we have seen for the display surface. And this is something you are going to see very often, that the display surface and the regular surface have lots of things in common. And this would be just one of them. And in my case, I want to give this surface a width of 100 and a height of 200. So now we have created a surface. Now the next thing we have to do is to actually display this. And this is going to happen in this while true loop. And let me get rid of the comments, they don't really help us all that much. So in the first indentation of this while true loop, I want to actually attach this test surface to our display surface. And this happens by first calling our display surface itself and then using the blit command. And blit stands for block image transfer, which is essentially a fancy way of saying you want to put one surface on another surface. And in here, we need two arguments. We first need the surface we want to place and then the position. And well, the surface we already have. It's just our test surface. And for position, for now, I just want to place it in position 0 and 0. And you are going to see in a second what that actually means. But now let's run the code. And well, what we can see is that we, can't see anything. And there's a specific reason for that. And the reason is quite simple actually. That right now, both our surfaces are plain black. So this surface here is black and this surface here is black. And if you put something black on something else that is black, you just get more black. It doesn't help you all that much. So what we have to figure out is how to add color to either of these surfaces. And well, fortunately, this is very easy to do because there's a specific command for it. And let me just run this on test surface because all we need is the fill command. And in the fill command, we can add a specific color. And Pygame has a couple of ways to add color. And the simplest way is to use a couple of named arguments that are predefined for Pygame. And there's a long list online that you can find that I would recommend to check out. I'll put a link in the description of the video. And one that we could use is just red, so that we want to fill this test surface with a red color. And now let's run the code. And now we can actually see our red surface in the top left of the screen. And now I really want you guys to think about why is this thing in the top left? That is really important to understand. And well, I guess let me actually explain what's happening here. Most importantly, our main window is this display surface and is 800 pixels wide and 400 pixels high. So this here would be the height. And let me actually put it on here. So this would be 400. And our width would be this entire width. And this would be 800. So this is just the arguments we specified up here. But there's one super important thing you have to understand about this. That you have to think about this window as a coordinate system. Think of it like in basic math, where you had a coordinate system that looked something like this, and on this you could have displayed a graph or something like this. And the really important part of this coordinate system is that the origin point was always in the bottom left. So this point was always 0 and 0. And if you wanted to go either to the left or upwards, you had to increase either of these numbers. Now, in the case of Pygame, this is slightly different. So what you have to be aware of for Pygame is that the origin point is in the top left. So this point here is the point 0 and 0. So if you want to go to the right, you still have to increase x. So let's call it plus x. However, if you want to go downwards, you have to increase y. Whereas in the system you learned in high school, if you wanted to go downwards, you had to decrease y. So this is slightly different for Pygame. And this is also something you see in lots of other game engines. And especially in the beginning, unfortunately, this is really confusing. And you will need some time to get used to it for basically any game engine. So something important to learn. So this is the first thing you have to understand here, that this is our origin point. So now when we place something at 0 and 0, we are looking at this point up here. Now this brings us to the second point, that when we have this test surface, there's one specific point we place when we place this surface. And the specific point we are placing is always the top left. So when we specify this 0 and 0 here, we are saying essentially that we want to get the top left position of this test surface and place it right in the top left of our display surface. And that way we have our surface right in the top left. So this is really important to understand for Pygame, to understand how the coordinate system works. With a bit of practice, this should come quite naturally to you. And let's actually do an exercise if you want to follow along. That right now, I don't want this surface to be in the top left anymore. Instead, I want it to be 200 pixels from the left and 100 pixels from the top. So try to implement this yourself. All right, welcome back. So let's try to do this together now. So right now, we are placing the top left position in 0 and 0, which is not appropriate anymore. Instead, I want this to be 200 pixels from the left and 100 pixels from the top. And now if I run the code again, we can see, let me draw on this again, we have this distance here is 200 pixels from the left, and we have 100 pixels from the top. So this is what these two numbers here illustrate. And again, we are placing this point here. So actually this line here should have been rather right on top of that. So I hope that makes sense. And if you get stuck on this, definitely play around with the different kind of points. It's really important to understand. And later on, we are going to learn a specific method to help us place something more deliberately. But for now, this should be good to go. So that way we can create a basic surface that has a plain color. But obviously that still isn't all that great because, well, our game isn't going to consist out of plain colors. Instead, we want to have actual images. And well, for that, we want to import some images. And well, the first we need for that is to actually have some images. And in my case, I have a couple of folders that are in the same folder where my code is. So let me open that one. And in here, we have our runner code. And then we have 3 more folders. We have graphics, we have font, and we have audio. And well, each of these contain what the name implies they contain. So let me open graphics. In there, we have, for example, a ground and a sky. These are what we are going to use in just a second. But there's also a couple of enemies and the player itself. So these are the tools I'm going to work with for now. And I will always assume that our actual code is in the same top folder as these 3 other folders. So when we import something, we have to specify a specific path. And if you want to follow along, keep the same folder set up. But all right, let me go back to the code. And now I want to get rid of all of this and instead import an image. And to import an image, we need pygame.image.load. And in here, we have to specify a path. And in my case, I want to go into the folder called graphics. And in that folder, we have an image called sky. And don't forget, we need the file ending. So in my case, this is .png. And well, with that, we have imported an image. So now let's run the code again. And we have our background. And right now, you can actually see the offset really well. Let me get rid of the offset entirely. So I just want to place this background on position 0 and 0. We can see the actual background. So this way, it's super easy to import an image. And one important thing to keep in mind here. Every time you import an image into Pygame, you are putting this new image on its separate surface. So any kind of graphical import is going to be a new surface. And in this case, I guess we can call this our sky surface because we can actually keep it. This one works pretty well already. So sky surface, and with that, we have our sky. And now, actually, this is something we can practice really well because there's another image inside of the folder that is called ground.png. And I want you guys to import this and place it somewhere in the bottom of the screen so we actually have something that looks halfway decent already. So try this yourself if you want to code along. Let's first create a new variable that I called ground surface. And to import this one, we are going to need the same setup. So pygame.image to load. I want to look at graphics. And in there, we have a file called ground.png. And I guess something slightly tricky about this, that this ground is not capitalized, whereas this sky is. And well, that's just my mistake. Sorry about that. But now we have our ground surface. So this is just another image. And let me place this right before our sky. So I again want screen.blit. This time I want ground surface. And for now, let me place it at position 0 and 0, just to see what happens. And now if I run the code, we can see an error because I made a typo. So this should be graphics. So now let's run it again. And now we can see that we can't see the background. And this again is intentional. So right now the problem here is that we have our sky, that's the main image we have. And our ground is right behind it. So our ground would basically be somewhere here-ish. But we can't see it because the sky image is right on top of it. So it overlaps it entirely. And the reason for that is that we first create our ground and then we put the sky on top of that. And Pygame always draws an order of when you call the code. So in this case, we first draw the ground and then we put the sky on top of that, which doesn't really help us all that much. But we can fix that very, very easily. All we have to do is to first draw the sky and then the ground. And now if we run the code again, you can see the actual ground. So now we're drawing the ground on top of the sky surface. And okay, right now we can see that our ground is way too high. So we have to place it a little bit further down. And well, in here, you can just play around with this and see what looks good. Let's try 300. This, I think, looks pretty good. So with that, we already have a fairly basic setup by just importing 2 images. So with that, we have basically already covered the 2 most basic kinds of surfaces. We have a surface with a plain color and a surface with an image. Now there's a third kind, that you can have a surface with some text. And here, the really important thing to understand is that every time you want to create text, you first have to create an image of the text and place that on a surface. And then you place that surface on the screen. And this is a slightly cumbersome process, although it is quite workable. But to work with text, you essentially need 3 different steps. Number 1, you first have to create a font that stores your basic font information. So the style of the font and the font size. Then in the next step, you use that font information to create some actual text. And this text is going to be on a surface. And then in the third step, you're placing that surface on the actual image. And that's really all you need. So let's actually implement all of this. So here I'm back in the code. And the first thing I want to do is to create a font. And I'm going to place this right in our starting variables. But you could basically place it wherever you want. And let's just call it test font for now. And to create a font in Pygame, we need pygame.font.font. And here again, the first letter of the second font has to be capitalized. Otherwise, this is not going to work. And in here, we have to specify 2 arguments. The first one is the font type we want to use, and the second one is the font size that we want to have. And for the font size, that's the easier one, it's just an integer. I went with 50. And for the font type, for now, I'm just going to use none. So we are using the default font of Pygame, but we are going to change this in just a second. So now we have a font, and later on we are going to use that to display the score. But for now, I just want to write some basic information so we know it's working. So that brings us to the second step. And let me place this right below our other surfaces. And in here, I want to create a new surface. And let's call this one the text surface. And to create this surface, we first need our test font and then the method render. And render is going to need 3 bits of information. Number 1 is the text information. Number 2, if you want to anti-alias it. And number 3 is the color. Let's go through those one by one. First up is the text. And this one literally is just the text we want to display. And in my case, I am just going to call this my game for now. Next up is anti-aliasing. And anti-aliasing basically means that we are going to smooth the edges of the text, which in this case is not something we want to do because we are working with pixel art. But if you are working with any text that's not pixel art, you basically always want this to be true because it makes your text look a little bit better. And then finally, we have our color. And here again, we can use the same kind of approach we have seen earlier. So in this case, I want to go with, let's go with green this time. So essentially, I'm going to create some text that says my game and is green. That's really all that's happening here. And with that, we have a surface. So now all we have to do is to use screen.blit again, use our text surface, and now place this somewhere in the middle of the screen at the top. And the numbers here don't have to be specific. We are learning later on a better way to place text. But I know in this case, our window is 800 pixels wide and 400 pixels high. So I want to place this roughly at 300 from the left and 50 from the top. And now let's actually run this. And there we go. We can see my game right in the top of the screen. Now, obviously, the font doesn't really match the rest of the game. And this we can work on right now, actually. So right now, we have the problem that we are using the default font of Pygame, which is none up here, which, well, doesn't look particularly good. But if we specify a specific file in here, we can use a much better looking font. And again, if you look at the folder, there's one specific file that we can use. So all you have to do is go to font, and in font, we have a file called pixel type. And this is a TTF file. So this specifies a font. And all I want to do is to import this file. So I specify it in here. So we have our font and then pixeltype.ttf. And now if I run the code, we can see a very different looking text. And this one I think looks much better. And I guess the green color doesn't work too well with it. So let's go with black for now. And yeah, this is looking much better now. So with that, we have the three different kinds of surfaces that we can draw some text, we can draw a basic color, and we can also import some images and display them. And this is already bringing us so much closer to an actual working game. But obviously right now, nothing is moving, which isn't great for a game. So let's actually start animating some of this. And the logic to animate something in Pygame is actually fairly straightforward. And here again, you have to remember the basic logic about video games I talked about earlier. So right now, we are drawing three different images: our sky, our ground, and our text. And we always place them in the same position. And the important thing you really have to understand here is that we are not drawing a static image right now. It just looks like a static image to us. But essentially, we are updating this entire image over and over again, 60 times per second. Now, the problem for us right now is that we are placing all of these images always in the same position. And this is why they look static to us. But if we were to update the position of each of these surfaces, we would get a moving image. So really, all we have to do in the most basic sense is when we use screen.blit, we don't use one constant position. Instead, we use a variable that we continuously update. And once we have that, we have a moving image. That's literally all it is. So what I want to do in this section is to get our snail enemy and move it from the right of the screen to the left of the screen. So, well, let's actually jump into our code and let's have a look at this. Here I'm back in my code. And the first thing I want to do is to import our snail image. So let me call this snail surface. And here again, we need pygame.image.load. And the path to the snail is graphics, snail, and snail1. There are multiple snail images because they show an animation of the snail itself. We're going to cover that later on, but for now, just work with snail1. So this would give us our snail surface. And let me actually draw this on the screen. So again, I want screen.blit. I want our snail surface. And let's place this about 600 pixels from the left and 250 pixels from the top. So now if I run this, we can see our snail. So this one is already working fairly well. And the problem here right now is that this is static because these two numbers are never going to change. We always place the snail in the same position. And well, we are placing all of this always in the same position. But we don't necessarily have to do that. What we could do, for example, is create another variable. Let's call this snail x position. And by default, this is going to be 600. So I just copy this 600 and place it in here. and then call snail x position. So all we really did is move this 600 into a specific variable. So right now, if we run the code, we are going to get the same result. Our snail is still static. But now what we can do is every time this while loop is running, we want to increase our snail x position by 1. So that every time we come to this line here, our snail x position is going to be increased by 1. And if I run the code now, we can see our snail moving to the right, because the x position is going to be greater on every single cycle of this while loop. And now if you want to move the snail to the left, all we need is minus equal 1. And now our snail is going to move to the left. And this is already working pretty well. And well, minus 1 is probably a bit slow. Let's go with 4. And yeah, this looks like a decent speed. Cool. But now, obviously, once the snail is leaving the screen, the snail is going to keep on moving to the left and we will never see it again. So this isn't great yet. But really, all we have to do to overcome this is use an if statement. That if our snail x position is too low, we want to again put our snail x position on a higher number. And this is a very simple if statement. And this could actually be an exercise. Try to figure out how you could place the snail on the right of the screen if it crosses the left side of the screen. Let's try it together now. So I want to use an if statement, and I want to look at my snail x position. And really, all I want to do is to check if this is smaller than, let's say, minus 100. And if that is the case, I want to get my snail x position and set it to something like 800. And now if I run the code, I can still see the snail. If it moves too far to the left, now it reappears on the right. And well, really all that's happening here is we look at this point here. So about minus 100. And if our snail x position, so this point here, gets further to the left than that, we are putting this position all the way over here. So this way it looks like our snail is looping. But really all we're doing is we're looking at this snail x position and we are updating it and then placing the snail in a specific part. So really all we are seeing right now is that our snail is continuously updated and our brain interprets all of this as a moving image. But okay, and I guess now what we can actually do, just to illustrate how the animation works, is this clock.tick right now is at 60. But if I set it to 1, you can actually see what's happening. So now let me run the code again. And now you can see the snail is just being updated a little bit further to the left every single time. And we're just drawing a new image every single time. And if this is slow enough, it looks like, well, our snail is very sloppy. And on the counter side, if I set this to something like 600, then our snail is going to be significantly faster. So because of that, our frame rate is really important, and we really want to make sure that this stays at least somewhat constant. So, all right, with that, we have a basic animation. So this is already going pretty well. Now, before we continue, there's one more thing I do want to show you guys. And let me just comment out all the images we have drawn earlier. So right now we have no sky, we have no ground, and we have no text. The only thing we are drawing is the snail. And now if I run the code, we get a very strange looking result. And the reason for that should make sense if you think about it for a tiny bit. That right now, all we are drawing is the snail, and the snail doesn't cover the entire screen. So every time we are updating this surface, we don't really get rid of the previous frame. We're just drawing on top of it. And since we are not drawing on the entire surface, we can still see the previous frame. And as a consequence, it just looks like we are stretching out something, which, well, looks terrible. So always keep in mind that you want to draw a proper background for your display surface. Otherwise, you will be able to saw the previous frames you are drawing, which looks very strange. Unless, well, it's something you actually want to achieve. But okay, so with that, we have our basic animation. And this is already looking pretty good, I think. And there's one more thing I would like to talk about before we get into the next section. And that is converting our surfaces. So let me go to the surfaces. Right now, we have imported 3 different surfaces. We have our sky, we have our ground, and we have our snail. And right now, all of them used to be PNG files. And this is fine for basic setup. However, ideally, we would like to convert all of them into something Pygame can work with more easily. And this we can do very easily. All we have to do is to add the line .convert after we are importing an image. And this I do want to do for all of the imported images. And all this really does is it converts the image to something Pygame can work with more easily, so our game is going to run faster. That's really all that's going to happen here. But now, if I run this, we're going to see something strange. So now our snail is going to look, well, slightly weird. And the problem here is that we didn't respect the alpha values. So this is all the white and black stuff behind the snail. And to get rid of that, all we have to do is change convert to convert alpha. And that way we are removing the alpha values. Now if we run this, now we can see our snail properly. And you can't really see a difference. However, now our game should be running faster, at least in theory. And especially once we have more stuff on the screen, this might become important. Although in our case, it really shouldn't make that much of a difference. But it's generally good practice, so don't forget to add this line every time you import an image. So with that, I do want to start working on the player character. However, there's one more really important concept we have to cover to really make the player character work. And that is called a rectangle. And rectangles in Pygame essentially have two different functions. At least in the most basic sense, they can do quite a few more things. But the two core functions of rectangles are this. Number one is that they're helping you place a surface much more efficiently and much more precisely. And number two, rectangles are going to help you detect collisions. Something we are going to see very soon. But for now, I do want to focus on using rectangles to place a surface on the screen. So let me explain what we are going to do. Right now, when we place the snail, we couldn't really place it precisely because we can only ever place the top left, which made it very difficult to place the bottom of the snail right on the ground. So ideally, we would like to grab a point on the bottom of the snail and place that point, which we couldn't do with surfaces by themselves, but something we could do with rectangles. And this is something that you see all the time in Pygame, that you separate placing images in two different steps. The actual image information is placed on the surface, but then the position information is placed in a rectangle. So essentially you are splitting your image into two different variables that you then have to control together. And much later on in this tutorial, we are going to see the sprite class. And this one combines these two so you can work with them more efficiently. So then how does a rectangle work? Well, a rectangle is rectangle. But this rectangle has a couple of points that we can work with. We can either get points that are a tuple, so they have an X and the Y position, or we can have points that are individual position, like left and right. You can see all of them on the screen right now. And we can grab each of these points and either measure or move them. And if we move any individual point on the rectangle, we move all the other points as well. So the points always stay relative to each other. And then we can use a rectangle to place a surface right in the middle of the rectangle. So a rectangle we could place, for example, in the top left, or in the center, or on the bottom mid, or on the mid right. We could literally place all of these points. And then we could use that information to place the surface right into this rectangle. And that way we are going to have much more control over how our surface is going to be placed. And later on, we can also use that rectangle to detect collisions. But that's coming later. For now, let's just use the rectangle to place a surface. So here I'm back in the code, and the first thing I would like to do is to import the surface of the player. So let's call this for now player surface. And this again, we just have to go with pygame.image.load. And here the path is in graphics. And for this one, the path is graphics player walk 1. So again, we have multiple images that we are later going to use for an animation, but for now we are just going to use one. And this again, I want to use with convert alpha, so it's going to run slightly faster. And let's just put this on the screen so we can see it. So I want to use screen.blit again. I want to place my player surface. And for now, let's place it, let's say 80 pixels from the left and 200 pixels from the top. And now let's see how this looks. Now we can see our player. And here you can already tell that there's a distance between the bottom of the player and the ground. So this area here, we want to bridge. But the problem is that, well, we don't really know how big this area here has to be. So placing just the top left of the player is very difficult. And to fix that, we are going to use a rectangle. So step number one for this is we have to create a rectangle. And there are different ways to do that. So for now, let's just call it the player rectangle. And in the most basic sense, you could create a rectangle by using pygame.rect. And in here, you could specify a left, a top, a width, and a height. And then this would create a rectangle. However, this is not something you see all that often actually, because ideally you want to have a rectangle that is the exact same size as this surface. And this we can create. All we're going to need is our player surface, so player surface, and then the method getRect. So all that this getRect does is it takes a surface and then it draws a rectangle around it. And then for this rectangle, we can specify a specific position where we want to place it. So in here, we could, for example, use top left and then give it an X and a Y position. So here, for example, I could copy the information from down here and just place it in there. And let's just start with that. So let me copy all of this. And now we have a rectangle that is in the same position as our surface used to be. And now when we use split, we can use a rectangle to place this surface. So all I have to do in here is insert player rect. So now essentially what we are doing, we are taking a player surface and we're placing it in the position of this rectangle. So now if I run this, we can see no real difference because the rectangle is in the same position where the surface used to be. But what we can do, for example, now use a different position on this rectangle. For example, we could use mid left instead of top left. And now if I run this, our player is slightly higher. Or we could also use mid bottom. And now our player is again in another position. And really what you have to understand about this is that we are placing this point here right at the bottom of the player. Whereas for surface, we always grab this point up here. So let me draw a rough rectangle around it. So for surface, we always place this point. But for a rectangle, we can grab any of these points around it. There are lots of points we can grab, and that way we can have much more control over what point we want to place. So this is super useful. And now we can use that to place the player right on the ground. And we know where the bottom of the player has to be because we know the ground is at position 300. So that's when the ground starts. So the bottom of our player has to be on this position as well. So let's say for the mid bottom, I want to go with 300. And now let's run this. And now we can see our player is touching the bottom perfectly. And here again, you might be wondering that this setup is kind of tedious and time consuming. So that whenever we want to place a surface and have any control over how it's going to be placed, we always have to create two variables. First a surface and then a rectangle. And I agree, it is quite cumbersome. And later on in this tutorial, we are going to see a sprite class. And a sprite class essentially combines a surface and a rectangle and places them in one class. And this makes it much easier to work with them. So later on, we are going to make all of this much more streamlined. But for now, I do want to work with them separately so you understand them better. So with that, we have our player rectangle. And now what we can do with this player rectangle, we could move every single point of this rectangle and then use that to control the surface. So for example, what I could be doing right in our game loop, I want my player rectangle and I want to grab any individual point from it. So for example, I could get the left of the player. And this I could either measure or move. So really what I could do here, for example, is just move this to the right. So add +1 to it. And now if I run this, we can see our player moving to the right. So this is how you would actually move something in Pygame. That you don't move the surface, instead you move the rectangle that contains the surface. But what you can also do is you can print this information. So I just want to print it. And now you can see that the left of our player is at position 48. So we know that this line here is 48, which can be really useful to measure different things. So this is stuff that is going to be really useful, but for now, I don't really going to need it. But something I do want to do, and this could be a really good exercise for you as well, is that I want you guys to update this snail, that we don't just use the surface to move it. Instead, I want you guys to place a rectangle around the snail and then influence that rectangle to move the snail. So if you want to code along, pause the video now and try this yourself. All right, let's try it together now. So my snail is this line here, and this snail exposition I don't need anymore. Instead, I want to create a snail rectangle. And let me use the surface line a bit more consistently. So instead of writing surface, I was write surf because it's a bit shorter. And I really like to keep this a bit more consistent. So for snail surface, I just write snail surf. That makes it a bit easier to read, I think. But okay, now to get this rectangle, I want to get my snail surface again and call get rect on it. And now again in here, I have to specify a position where I want to place this rectangle. And here again, I could use mid bottom again, but just to mix things up a bit, I could use the bottom right, for example. Although in this case, it really doesn't make much of a difference. And where I used to place this was at position 600, and now for the height, I want to go with 300. So again, the important coordinate that we have to worry about is this ground here. This is where our snail has to be on top. So when we specify the bottom of our snail, it has to be the same position. So just keep that in mind. And now we just have to use that rectangle to place the snail. And that happens on this line here. So now instead of placing it in this one position, I just want to use my snail rectangle. And along with that, we don't need all of this information anymore. So let me get rid of it. And instead, I want to do all of this with a rectangle. But let's first try if it works in the first place. And there we go. Now we can see our snail right on the ground. This already looks much more realistic. But now I do want to move the snail. And well, for that, all I need is my snail rectangle and then get one of the points that we want to move. So here you can really pick any point you like. Let's say in my case, I want to go with X. And this, I just want to move by minus equal, let's say 4. And now if I run this, we can see our snail moving again. And now if we want to move the snail back to the right of the screen, all I need is an if statement and get my snail rect again. And here we want to measure if our snail leaves the screen. So effectively what I want to know is when the right side of the snail is smaller than 0, because then I know the snail has left the screen. So what I want is to get the right side of the snail and check if this is smaller or equal to 0. And if that is the case, I want to get my snail rect again. And now I want to place the left. And this is supposed to be at position 800. Because 800 is our right side of the screen. It's that position up here. And well, with that line, this snail should be working okay. So let's try this now. And we can see our snail moving to the left, and now it reappears. And this way we have much more control over the different points of our snail. So this is super useful. But this is essentially it when it comes to using rectangles to position surfaces. It really is quite tedious, especially early on, but once you get used to this, this is actually quite a powerful system. But alright, with that one, we can learn about the second aspect of rectangles where they are really useful, and that is collisions. So what I want to do for this section is to get a collision between our snail and our player. And this is actually super easily done with rectangles, because all I really want to do is to check if there's a collision between the player and the snail, or the rectangles that contain them. And this can be done with the collide rect method, which just checks if one rectangle is colliding with another rectangle. That's really all that's happening here. So let's jump right into our code and let's implement this. So here I'm back in the code, and all I want to do is go right to the bottom. And in here, I want to check if my player rect is colliding with the snail rect. And really, all I have to do is to get my player rectangle and use collide rect. And in there, I have to place the other rectangle I want to check against. So this would be my snail rectangle. And this method returns either a 0 or a 1. So if there's no collision, we get a 0. If there is a collision between these two rectangles, we are going to get a 1. And that information we can then use in an if statement. But first, let me print the entire thing. So just so you can see what's actually happening here. So now if I run this, we can see lots of zeros, but once the snail is colliding with the player, we can see ones. Then we go back to zeros, then we go back to ones, all the way down here, and this happens over and over again. So we can tell that this here is returning a 1. So this I can then use in an if statement. So in here, you could write if this is equal to 1, but since Python automatically converts a 0 to false, we don't really need that. So this line here by itself is fine as well. And well, if that is the case, let me just print collision, just to see if it works. And now if I run this, we can see a collision once the snail is colliding with the player. So we know this line here is working. But there's one thing you really want to keep in mind here, that this might trigger multiple times, because right now, when our snail is overlapping with the player, Pygame checks every single frame of the game if there's a collision or not. So if we just had this line, then this collision might trigger multiple times, which if you have some kind of health system would be a big problem. Because later on we are going to end the game once there's a single collision. But if you have a heart system or some kind of health bar, you really want to make sure you only have a single collision and then you have some kind of invincibility frames. Something lots of games actually have. But in our case, this kind of collision system is fine. And this would be then the basics of collision. Now, there's a different kind of collision that you can use with rectangles, and that's collide point. And this is not something we are going to use too much, but it is also quite important. So I do want to talk about it. And all that collide point really does is it checks if one point collides with a rectangle. The name should kind of make sense here. And this isn't something you are going to use too often. However, if you ever want to click with a mouse on something, then collide point is incredibly important. And this is kind of why I'm going to talk about it. So in this section, we are going to talk about collide point and using the mouse in Pygame, just as a small interlude. We are not going to use it too much. So let's go through both of these and let's first talk about collide point. We are basically calling this like collide rect. So we first need our rectangle and then calling this as a method. But now as an argument into collide point, we don't pass in a rectangle. Instead, we have to pass in a tuple with an X and a Y position. And then Pygame checks if this one position is inside of the rectangle or not. And then it again is going to return something that we can use in an if statement. So far, so good. But now, how can we get individual points? Or rather, how can we measure the mouse position? And for that, Pygame has two different approaches. We could either target the mouse with pygame.mouse, or we could look in the event loop and check the events that check the mouse position. Those basically get you to the same position, but there are two different ways to approach it. And well, I'm going to demonstrate both. So the first one is pygame.mouse, and this one gives you lots of information about the mouse. For example, the position or what buttons are being pressed. You could also set the position of the mouse or if the mouse is visible in the first place. And if you check the documentation, there is quite some more stuff you could be working with. But in my case, I am only going to work with get pressed and get position. So get the mouse buttons pressed and get the position of the mouse. Now, besides that approach, you could also use the events. So when we have the event loop in there, you could also work with the mouse position. But that was quite a bit of talk. Let me actually implement all of this. So here we are back in the code. But now what I want to do is to check if our mouse is also colliding with the player. And just to make this a bit easier to see, I'm going to comment this one out for just a second, so we don't get too much at the same time. So I again want to get my player rectangle, and I want to get collide point. And in here, we have to pass in a tuple that has X and Y positions. So this is the point we want to measure if it is inside of the player rectangle. And then again, we can use this inside of an if statement and check and print if there's a collision. Now then the important question is, how do we get this X and Y position? So let me put this inside of a new variable that I'm going to call mouse position. And to get the X and the Y of the mouse position, all we need is pygame.mouse.getPos. And this would give us an X and a Y position that we can then use inside of this. So all I want to do is to copy my mouse position and place it in here. So now let me activate the mouse. And now if I run the game, now you can see my mouse. And if I hover over the player with my mouse, you can see collision. So this one is already working quite well. So really all we have done here is we have used this pygame.mouse and used getPos to get the position of the mouse. This one should be quite straightforward. Now pygame.mouse has quite a few more methods that we can use. And one would be getPressed. So let me call this one if we are hovering over the player rectangle. So pygame.mouse.getPressed. And of course, I do want to print all of the information. And now if I run the code again, and you can again see my mouse, I hover over the player, and now you can see false, false, and false. And this is a Boolean value for each of my mouse buttons. So if I press any of the mouse buttons, and let me scroll down a tiny bit here actually. So now you can see all of my mouse buttons, and if I press the left mouse button, you can see true. If I press the right mouse button, you can see true on the final Boolean statement. And if I press the middle mouse button, you can see true in the middle. So this is basically which mouse button I am pressing. So that way you could check if I am pressing different mouse buttons. So that way you could check what the mouse position is and what buttons are being pressed. So this would be one way to approach this. Now what we can also do, in the event loop, we can also access the mouse position. So we want to check for a different kind of event, and this would be if event.type is equal to pygame.mouseMotion, all in uppercase letters. And this would give us the mouse position. And this would only trigger if we move the mouse. So if you don't move the mouse, this is not going to give you anything. But once you do have it, you can print the event position. So this would then give us also the mouse position. And now let me run this code again. Now you can see my mouse again. And now, okay, let me scroll down again. Now you can see wherever I move my mouse, you can see the actual position. So if I move to the top left, you can kind of get closer to 0 and 0. And if I get to the bottom right, you can see close to 800 and 400. And well, that way we can also get our mouse position. So this would be another way to approach this. Now, another thing that you could use in here is mouse button up and mouse button down. So this would either check if we are pressing the mouse button down or if we are releasing it. So let me start with mouse button down. And if that's the case, I just want to print mouse down. So now let me run this again. And let me spell all of this correctly. Now this works. And now whenever I click, we get mouse down. And now if we change this to mouse button up, this is only going to be triggered once we release the mouse button. So let me go with mouse up. And if I run this now, well, you can't really see it, but now I'm pressing the button and nothing happens. Only if I release the button, we can see mouse up. So this would be a good way to check if the button is pressed or released. But this is basically all you have to know to use Pygame with a mouse. If you check the documentation, there's quite a bit more about small details, but this is the basic and the most important stuff. And let's do one small exercise to finish this part off. That I want you guys to use the event loop to check if the mouse is over the player rectangle. And well, pause the video now and see if you can figure this out. Let's try together now. Obviously, I want to work in this line here and figure out how I can use that information to check if my mouse is over the player rectangle. And well, the first thing I need to get is the mouse position. So I want to go with mouse motion. And once I have that, I can print the event position. So this would be the first step to approach this. And this is what we have seen earlier. But now what you have to be aware of that this event position is also going to give us an X and a Y position. So this is something we can use in collide point with a rectangle. So all we have to do in here is to check our player rectangle and then use collide point with the event position. And use this in an if statement. And if that is the case, I want to print, let's call it collision. And let me disable and comment out all of this down here so we don't get confused with that line. So now in theory, this should print a collision. And let's try this. And now we can indeed see collision. All right, and with that, we would be having our mouse collision. Now, for now, I am going to comment all of those out, but we will later on revisit them to implement a proper collision for our player and for our obstacles. But before that, there's one more thing I would like to address, and that's the score. And right now, the score, or my game, is not really centered in the middle of the window. So this is something I would like to address. And well, this we can also use with rectangles quite easily. But along with that, I would also like to highlight another functionality of rectangles, because rectangles can be used to draw images on the screen. But let's talk about that after we have centered the score. So we go step by step. So let's get started by centering the score. And this again could be a challenge for you. So if you want to code along, try this yourself right now. All right, so let's try to do it together. And here we have our text surface. And let me put this in like a separate paragraph. And again, I don't want surface as a whole word, I just want surf. I think that's a bit more readable. So a bit further down, we have our text surface here. And actually, I think a better way to call this would be score surface. That's making more sense. So let's call this score surface. Sorry about the renaming. I should have really thought about this earlier, but never mind. So now we have our surface again. And the first thing I want to do is to create a rectangle. So I have score rect, and this is going to be our score surface. And I want to get rect. And this score rectangle, I want to be right in the center of the screen and roughly in the top of the screen with a little bit of an offset between the top of the window. So the point I want to place is the center. And in here, again, we need X and Y. And we know our entire window is 800 pixels wide. So half of that is going to be 400. And I think the original offset of 50, so the value we have specified down here, should still be fine. So all I'm going to do is to place this 50 in here and we are good to go. So all I need is 50. And then I want to get this score rectangle and place it in the score surface. And now if I run this, we can see my game right in the middle of the screen. So this is working quite well. So far we have used rectangles for two different purposes. We have used them for positioning and for collisions. But there's a third one that you also see fairly regularly, although not as often as the first two. And that is you can use rectangles to draw. Or at least rectangles are part of the drawing module. You can use other tools to draw as well. So let me explain. Within Pygame, there's a submodule called draw. And in draw, you could, for example, pass in a rectangle, and then you would be drawing this rectangle. You could also be passing in a rectangle, and then you would draw a circle inside the boundary box of that rectangle. But you don't necessarily have to use a rectangle. You could also draw a line from one point to another, where you would just specify 2 points. You wouldn't need a rectangle for that. And this is also quite a useful thing to work with. So how I want to illustrate this is I'm going to give our score some background color, so it looks a little bit nicer. Oh yeah, and along with that, we are also going to talk about colors after that, but step by step. So the first thing I want to do is I want to draw this score rectangle. And well, all I have to do for that is in the line before that, I have to call pygame.draw.rect. And all that's happening here is we first tell Pygame we want to draw a certain thing with the draw module, and then we want to specify what kind of shape we are drawing. In this case, it's going to be a rectangle. But if you look at the documentation, there are quite a few more shapes that you could be drawing. For example, a polygon or an ellipse. But in my case, I will just draw a rectangle. And in here, we have to specify 3 different arguments. We first need the surface we want to draw on, so our display surface in this case. Then we need a color, and then the actual rectangle we want to draw. So in my case, this is actually quite easy. So I want to start with the screen itself. That's our display surface. Then I'm going to need a color. And for now, we are just going to use the default colors. So let's go with pink. It's going to look terrible, but that doesn't matter for now. And then I want to draw the actual rectangle. So score rectangle. And now if I run all of this, we can see a pink background that doesn't actually look all that bad. And in here, well, you can see that the background covers the text just about. There's no margin whatsoever. And that isn't great. And well, you can work with that quite a bit more. So if you go to the documentation, there are quite a few more arguments that you could be passing into this. The one you are probably going to see the most are width and border radius. So let's specify both of those just to see how they look like. So argument number 4 that you could pass in here but don't have to would be the width. And let's just pass in a 6 for now and let's just see what happens. And now we can see something probably slightly weird, that we only get the surrounding, we don't get the actual rectangle itself anymore. So this is something you should be aware of when you work with this, that once you specify a line width, Pygame stops drawing the center of the rectangle. So this is a little bit annoying. But now I can also specify another argument, and this would be the border radius. So let me put a 20 in here, and now we have quite a bit of rounding. But in my case, I don't want to have any border rounding, I just want to keep the border width. So now how could you draw a rectangle that both has a border width and a center that's colored? And well, all you really have to do is to copy this line and then add one without a width and one with one. So now if I run this, we can see that we have a bit more of a margin around the text. And let me change this to a 10. And now let's try this again. And this is looking marginally better. Not great, but I would say good enough. So this is something you could work with to draw different kind of shapes. And let's just play around with this, and this could be a really good exercise. So I want you guys to look at the documentation and just draw a line from the top left of the screen to the bottom right of the screen. So check out the documentation and see if you can figure this out yourself. All right, welcome back. So right now, here's the documentation. And in there, we have two methods that can be used with us. We have pygame.draw.line and pygame.draw.antialiasLine or AA-line. And those two basically do the same thing, except one line is anti-alias, the other one isn't. And those two, for the most part, are going to be identical. So I'm just going to work with line. And if we look at this one in more detail, this one is going to need 5 different arguments. We have a surface, a color, a start position, an end position, and a width. So that's really all we need. And well, let's implement that. So here I'm back in the code, and let me add a new line with pygame.draw.line. And in here, we are going to need 5 different arguments. So the first one is the screen, or what surface we want to draw on. Then we need a color. For now, let's go with gold. And then we are going to need 2 points. So the start point and the end point. And both have to be tuples. And since I want to start in the top left and end in the bottom right, I have to start with 0 and 0. So the top left and the bottom right is 800 and 400. And now I have to specify a width. So let's go with 10, but you could leave out this argument, but let's specify it. And now if I run this, we can see a line going from the top left to the bottom right. And even better, what you could, for example, be doing in here is replace this with pygame.mouse.getPos. And now what you would get is a line that always follows the mouse, which is kind of cool, I think. But we don't really need it, so let me get rid of it. And let's do one more that I just want to draw a circle. And this would be an ellipse. And for the ellipse, we would again need the surface to draw on. Now we need a color. Let's go with brown. And this rectangle is going to be the bounding box for this surface. And really what we can do in here is generate this surface on the fly. And we could do one of the rectangles we have created earlier. Although what I also want to cover is that we haven't created a rectangle from scratch yet, which can also be useful sometimes. So all I want to do in here is pygame.rect. So we are creating a rectangle right inside of the method. And this is going to need 4 arguments. We need the left argument, the top, the width, and the height. So let's place this, I don't know, 50 pixels from the left, let's say 200 pixels from the top. I want this to be 100 pixels wide and 100 pixels high. And now let's run this. And now we are getting a circle, or well, an ellipse with an equal width and height, but that doesn't really matter. But we do have a problem right now, that the colors don't really match up. So when I open this again, the black text and the pink background just don't look very good. And the problem here is that for now, we always relied on the predefined colors, which can be okay for a starting point, but don't look too great. So how could we specify more specific colors? And there are two ways to specify colors in Pygame, and this also applies to basically any other program. And they're called RGB colors and hexadecimal colors. And they do essentially the same thing. So let me start with RGB colors. All that RGB stands for is red, green, and blue. That's really all it means. And all we are doing here is that we are specifying how much of each color we would like to have. And then Pygame mixes all of them together, and we are getting one customized color out of that. That's really all we are doing. And for each color, you can choose between 0 and 255, with 0 being the absence of the color and 255 being the full color. So for an RGB value, we would specify a tuple with 3 different values. One with the amount of red, one with the amount of green, and one with the amount of blue. And for example, if you had an RGB tuple with 255, 0, and 0, you would have a plain red color, because you would have only red and no green or blue. And now for hexadecimal colors, we are basically doing the same thing, we just write it down in a slightly different way. So we don't have a tuple anymore, instead we have the hash symbol followed by 6 numbers. And the first 2 numbers are for the red color, the third and the fourth number are for the green color, and the final 2 are for the blue color. And then for each of these 2, we can specify the amount of each color we want to have. And with that, you basically have the same outcome as RGB. Now, how you count how much of each color you have for this is slightly weird, because the lowest possible value is 0 and 0, and the highest possible one is F and F. So the counting here is slightly different. If you want to read more on this, I put a link in the description. But essentially, you are never going to create your own code. Instead, you would use something like Photoshop or some kind of website to create a color for you. Nobody ever really reads these things by themselves. They're not really made for that. So with that, we have some colors. Let's actually implement them. And there are 2 colors that we are going to need. One is the color for the text and the other is the color for the box behind it. And I'm going to use an RGB color for the text and a hexadecimal color for the box, just to show you how both are going to look like. And here are the 2 colors I am going to use, so you can see what they look like. So let's implement all of this. So here I am back in the code, and if I run all of this, we can still see our pink box with the black text. And let's start working on the text itself. And to change the color of the text, we have to work up here. And we have to update the text when we create the surface. And right now, we are just creating a black text inside of a surface. And I'm going to get rid of that and instead replace it with an RGB tuple. And this one is going to have 64 for all 3 colors. So we have 64 for red, 64 for green, and 64 for blue, which gives us a fairly darkish gray. So this would then be the text. And that's really all we had to do. Now if I run this again, now our text is looking slightly more grayed out. It still doesn't look all too good because the background is pink, so let's work on that one. And for that, I have to scroll down a little bit, and now I want to change this pink here to a different kind of color. And this happens with an hexadecimal string, although you could also use an RGB string. And in my case, I have a string that looks like this. And really important here, do not forget the hashtag in the beginning. That one is super important. If you don't include that one, it's not going to work. But this is, well, it's a bluish color. Let me run the code, and now we can see that this color of the text box is the same color as the background. So this is, I think, the best kind of color for this. And here again, if you want to choose your own colors, either for RGB or for hexadecimal, there are loads of programs that you can be using. For example, in Photoshop, you can see both the RGB and the hexadecimal color. But alright, so with that, we have the different colors. Next up, I want to start working on the player. And this is going to involve a couple of different steps. Number 1 is I want keyboard input. And well, most games are used with a keyboard, so this one should be quite straightforward. But what I essentially want to achieve is that if the player presses space, our player is going to jump. So we have to implement a jump mechanic. But to implement that, we are also going to need gravity. So those two things are going together, that you can both jump and fall at the same time. But once we have that, there's one more thing that we do need, and that is some kind of floor. Because if we can jump and fall down, if we don't continuously jump, our player would eventually fall into nothingness. So this is then the third thing we have to implement. And these are three things that are kind of independent of each other, so I'll go through them step by step. And let's start with keyboard input, because this should be the simplest one by now, because we have already seen something similar with mouse input. And keyboard input isn't all that different from that. And here again, we have two different ways of getting input. We could either get all of the keyboard inputs with a specific method, or we could use the event loop. And well, there isn't really all that much to talk about. Let's actually go straight into the code and let's implement all of this. And then we are going to look at both kinds of input. So here I'm back in the code and it is already taking shape quite a bit. But now what I want to do is to get all the keyboard input. And let's start with the first one, that we want to use the submodule called keys. And to access that, we need pygame.key. And in there, we have a method called get_pressed. And this one is going to return an object that contains all the buttons and their current state. So if they're being pressed or not. And well, let's just print the entire thing and see what's going to happen. And right now, you can see a ton of different zeros. And each of these zeros is going to stand for one button, with 0 meaning the button is not pressed and 1 meaning the button is pressed. So this is very similar compared to the mouse. And that information we can use to, well, access the button and see if it's pressed or not. And how you would usually do that, let me stop all of this, is you would use this kind of like a dictionary. That you would first store it in a variable. Let's say in my case, I'm going to call it keys. And then you can use keyword arguments to find specific buttons inside of this object. So what we could, for example, do is look for one specific button. And if you look online in the documentation, you can find all the constants that represent specific keys. There's quite a long list of different things you can do. The one I want to look for is called pygame.k space, which stands for the space button. And this one is going to return either a 0 or a 1. And that information we can again use in an if statement. So if that is the case, let's say I want to print jump. And now let's run this and let me press space. And here again, we can see jump. So this is working pretty well. So this would be one way to access all the different keys that you can have. But again, this we don't really want to do right now. So let me comment it out and let's look at the other way. Because you can achieve the same thing in the event loop as well. So in here. And let's work on that actually. And in here, you have a little bit more control over what you do with the keyboard. Because in here, you wouldn't just check for what button was being pressed. Instead, you would go through a two-step process. Number one is you would first check if any button was pressed in the first place. And only then would you check the specific button that was pressed. And then you can do the same way with a button being released. This is again kind of similar compared to what we have done with a mouse click. But all right, let's implement it here. So I want to look for an event.type that is equal to pygame.keyDown. And if that is the case, for now, let's just print key down. And just to illustrate what we can also do, we can print key up. So this would be releasing the key, and then we can print key up. And now let me run all of this. Our game is still working. And now let me just press a button. And we can see key down on the bottom of the window. And I keep the button pressed for now. And this is why you can't see key up. But now if I release the button, now we can see key up. So this way we can separate if the button is being pressed or released, which can be quite useful in some instances. So this would then be one way to check if a button was pressed in the first place. What if I want to check for a specific key here? Well, all we would have to do is look for an event key. And this we would compare with the same keyword arguments that we have seen down here. So here again, we could use pygame.kspace. And if that is the case, now I want to print, let's call it jump again. And now if I press space, we can see jump and also key up. So this one is working super well. And well, with that, you basically have all the different ways that a player could enter information into the game. So you have seen different ways to work with the mouse and also with the keyboard now. And you can do this either in the event loop, or you could do this inside of the game itself. And now I guess there's one question that's been looming over input so far. That why do you have two different methods in the first place? Why do you need that? And the answer here is actually quite obvious. That later on we are going to learn about classes that are ideally self-contained. And this would also include input methods. And for that, it is super useful to have input that we can work separately from the event loop. But for most of the time, the event loop should be the good way to go, because then we have all of our input nicely organized in one place, so it's easy to work with. But again, this is something you are going to understand later on once you actually work with it. So for now, just don't worry about it too much. So now we have all the input we need. And I don't think there's too much we need to practice with this. So let's go straight to the next part. And that is that I want to give our player the ability to jump and also to fall. So what do we need for that? And well, the first thing that we are going to need is some kind of gravity, because well, our player needs to be able to fall. And here's a slight problem that we are going to have. That in reality, gravity isn't a linear function. Instead, it's exponential, which basically means that the more you fall, the faster you fall. And if that doesn't happen, falling is going to look really weird. It looks like we're in space. So we have to create some kind of method that looks like our player is going to fall in an exponential speed, which is kind of annoying to do, so we are only going to imitate that. We're not going to replicate it, although it's something you could be doing. But essentially, all we're going to do is we're going to separate this process into two different parts. Where number one, we are going to create a variable that has a gravity. And this gravity is going to increase. So it's just a number for now that just increases constantly. And then we're going to add this number to move our player downwards. And since our gravity is getting larger and larger, it looks like our player is falling at a faster and faster speed. It's not exponential, but it starts to look quite a lot like it. And especially since we are not falling that far, this is not something that a player would notice. And this is something you see really often in video games, that game developers just don't really care about physics as long as it looks and feels good. If it's actually physically accurate, nobody really cares. But alright, that was again lots of talk. Let's actually implement all of this. So here we are back in the code, and the first thing I want to do is to create some kind of variable that tracks gravity. And this, let me put it right below the player. So let's call this player gravity. And by default, this is going to be 0. But now what's going to happen in our game loop? And let me separate the player a little bit, and let's add a comment here so we know we're always working with the player. That should organize our code a little bit better at least. So before we are drawing our player, I want to increase the gravity by 1. So the player gravity plus equal 1. So on every single cycle of the game loop, we are going to increase our gravity by a bit. But right now, this isn't going to do anything because this player gravity and this player rectangle are, well, they're not connected. So they don't influence each other whatsoever. And, well, let's change that. So what I want to do is this increasing gravity, I want to use that to move the player downwards. And this could actually be a really good exercise for you guys. So I want you guys to use this player gravity to move the player downwards continuously. So pause the video now if you want to code along and implement this yourself. All we have to do is to get our player rectangle and then target one of the vertical attributes. Doesn't really matter which one. In my case, I'm just going to go with Y. And here, all we have to do is to plus equal this with player gravity. And now let's try this. And now we can see our player falling downwards. Obviously, this isn't going to look too great because our player just disappears immediately. But let me explain what's happening here. That at the beginning, our player gravity is 0. And then we add plus equals 1 to it, so we will get 1 out of it. And this is then what we would add to our player gravity. So then our player gravity would be 301. But on the next cycle of the loop, let me use a different color for that, we would start with 1 already, and we would add 1 towards it. So now we would get to 2. And now if we add this to the player gravity, we would get 303. So we have an increase in speed in terms of how fast we are falling down. And this is going to look very much like our player is falling in real-world gravity. And this to our primitive brains looks like the player is falling at the natural speed, although it's not real gravity. So with that, we have to find a countermeasure that our player has to jump upwards. And this is also something we can implement quite easily, because right now, this player gravity is moving our player downwards because it's positive. But if this number were to become negative, our player would move upwards. And let me actually demonstrate this. So when I set this player gravity, right now it's 0, but I could set this to -20. And now if we run the code, we can see we have 1 jump. Because we initially moved the player upwards, but then we're moving it downwards at an increasing speed. And this we don't want to do when we create the player gravity. We only want to do when we are pressing a button. So in here we want to do it. And well, this is then all we have to do. So we have to get our player gravity and set this to -20. And let me get rid of key up because we are really not going to need it. And now if I try this again, I can see if I keep on pressing space, we have a jumping player. Still not particularly realistic, but we are definitely getting there. So with that, we have gravity and the ability to jump. And actually on that note, I also want to reactivate this mouse motion to click on the player. So what I want to do in here is if the player is clicking on the player, I want the player to jump as well. And this could again be a good exercise for you. That just implement some kind of system that if the user clicks on the player, then the player jumps as well. So pause the video now and try this yourself. So to fix this kind of problem, we have a couple of different ways to go. For example, we could check our mouse position and then check if there's a collision and we are pressing the mouse button. Or we could check if we are pressing the mouse button and then there's a collision, and that's basically the same result. In my case, I first check if the mouse button was pressed in the first case, and then I check for a collision. And the different approaches here really aren't going to make a big difference. Although they might make a small difference. And keep that in mind, that if we first check for a mouse button pressed and then we check a collision, is more efficient than checking for a collision and then for a mouse button press. Because checking for a mouse button is much easier than checking a collision. And it's not going to make much of a difference, but if you have 20 or 30 of these small differences, they might actually add up to a faster game. So just keep that in mind for actual games, that you always want to have the most efficient way to run your game, which can make a difference. But all right, let's actually implement all of this. So here I'm back in the code, and I first want to check for mouse button press. So this is mouse button down. So we check if any mouse button was being pressed. And I'm not going to care which mouse button, so any mouse button is fine. And then I actually already have all the code we are going to need. So if player collide point event pos, this still works, because the event position we can always check. And well, if that's the case, let me put it on the next line. I just want to copy this code here and then add it in there. And let me actually try if this is going to work. This is going to be slightly difficult to do, and yeah. Now if I click on the player, we can indeed see that the player is jumping if I click on it. Although it's much harder to do than just pressing space. But alright, this is indeed working. So with that, we have some kind of gravity and a proper jump mechanic. And there's one more thing I do want to do, and that is to get rid of all of this stuff down here. Because we are not going to use any of those for a while, and I want to keep my code clean. So, alright. With that, we have quite a bit of progress. Now there's one more thing I do want to achieve, that I want to create some kind of ground for the player. And here you might be tempted to do something very inefficiently, that you might want to check the collision between the ground and the player. And anytime the player is colliding with the ground, we want to move the player up. And this would be possible, but it also wouldn't be a good solution. For the simple reason that it's complete overkill. That we don't really have to check for collision with the ground because we effectively only need 1 point. And that is the point 300 on the y-axis. And if the player is going below that, we want to move the player on top of it. So effectively, we don't want to check a collision, we just want to check if the player is on that point. So here we are only going to simulate a collision. There's no actual collision. All we really are going to do is if the player is below 300, we are going to put the player at position 300. And that way it's going to look like the player is standing. But in reality, it really isn't the case. So here, back in the code, I want to add one more line before we draw the player. And that is if player rect.bottom, so we check the bottom of the player, is greater or equal than 300. So this position here. And this is why I've chosen 300, that the top of the ground and the bottom of the player, once those two are identical, or if the player is overlapping with the ground. If that is the case, I want to get my player rectangle and the bottom of it and set this to 300. So every time our player is exceeding the ground, we are going to set the player on top of the ground. And well, that's all we have to do. So now our player is going to stand. And if I jump, we are falling down, and well, the player is still standing on the ground. So now it looks like there's a collision with the ground and the player, but in reality, there really isn't. And again, this is a common thing for video games, that you just simulate something that looks realistic to us, but well, we're not really creating the real thing, because that would be really difficult to do. So, all right, with that, we are almost done. There's one more thing that we have to address, and that is, let me run the game again. Now, if I keep on pressing space while we are in the air, our player keeps on jumping. So effectively, we are flying. And well, this I want to get rid of. And this we can do quite easily. All we have to do is in these two lines, we have to add one more condition that we are only able to jump if we are touching the floor. And this again could be a small exercise for you. So again, if you want to code along, try to figure this out yourself. That how can we check if the player is touching the ground? All right, so all we really have to do in here is to check if our player rectangle and the bottom of it is greater or equal to 300. Effectively the same condition we have used down here. And well, that's literally it. And don't forget an and between the two so it works. And this we have to do for both of these if statements. You could also put all of this inside of an if statement, it really doesn't matter. But now, let me run all of this again. And now I keep on pressing space, but the player is only going to jump if we're actually touching the floor. So this is then getting much closer to an actual game. And in here, I can almost try to play the game, where we are, well, having almost a game. Nothing really happens yet if our player touches the snail, but that comes next. So let's talk about that part. That I want to end our game if our player touches one of the snails. And well, we already have the collision mechanics, so this is something we can already implement. And let's actually do this right now. So here I'm back in the code, and again, somewhere in our game loop, I want to implement a function that ends the game if our player touches a snail. And let me add a comment first. So we have collisions here. And all I want to check for now is if our snail rectangle is collide rect with the player rectangle. And this has to be an if statement, of course. And if that is the case, for now, I just want to end the game. So I just copy those two lines, and if this is working, then our game should just end if these two collide. So let's run all of this, and we can see our game is ending once the player is touching the snail. So this would kind of work, and we would actually have a game at this point. Obviously not a very good game, but this is kind of working. But instead, I want to do something slightly different. That I have two states in my game. One is the actual game we have already seen, but then I want to have some kind of start screen. so that if the player is colliding with an object, we are coming to an overview screen where the player can see the score and press a button to start again. So for that, we have to figure out how can we have different states in our game. And well, the answer here is actually surprisingly simple. That right now in our game loop, we are drawing and checking certain things. And all we really have to do is to put all of this inside of an if statement. So for example, if our game is active, we want to draw all the stuff we have seen so far. However, once we are colliding, we are setting this game active to false, and then we have an else statement that draws something else. That's literally all we have to do. Now, obviously, this is a very simple setup and not particularly good for really complex games. But it is the basic logic you have to understand to basically create any kind of multi-level system. So let's start by implementing that one. So here I'm back in the code, and right at the top, because it's an important variable, I want to create game active. And this by default for now is going to be true. And then further down, all of the stuff we have drawn so far. So literally all of this bit here, we only want to do if our game is active. And actually, if I go further up, this part here as well, I only really want to do if our game is active. Although that we are going to work on later. For now, I just want to put all of this here into an if statement. So I'm going to indent all of it and add an if statement. So if our game is active, then I want to do all of this. And since this game active right now is true, I can run the game and we have the same outcome. Cool, so this is still working. But now what I can do is if our snail is colliding with the player, I want to set my game active to false. And now if I run this and our player is colliding with the snail, well, nothing is going to happen anymore. Our game stops. For the simple reason that we don't update any of this anymore, but we don't draw anything on top of it. So all we can really see is the last frame of this game loop. But now what we could, for example, do is add an else statement in here. And let's say for now, I just want to screen.fill and let's add yellow, just to see what happens. So now I use the game and now we have yellow. And in here, we could literally add any kind of code we want. So this could be much more extensive. And we are going to add quite a bit on this later on. But for now, this would be a pretty good way to separate our game. That all of this code here is going to be our actual game or the game part of our game. And all the stuff down here is going to be some kind of intro or menu screen. And that way we can separate our game into logical parts that are also going to be easier to work with. And well, with that, the one thing we have left to do for this part is to set up some kind of way to restart our game. And well, all we really have to do for that is if our game active is false, we have to check for some kind of player input. And if that's the case, we are going to restart the game. And this is then going to bring us up here. That right now, we only want to check all of this if our game is active, and then we want to do something else down here if the game is not active anymore. And this could be a good challenge for you, that if game active is false and we're pressing the space button, we want to restart the game. Try to implement this yourself and see how far you get. The first thing we have to do, just like with our main code, we want to put all of this inside of an if statement. That if game active, we are checking all of this. And what we can do now is add an else statement in here. And I just want to check if we are pressing this space button. So let me copy this line here. So right now we're checking if our key is down. And we could also put these two lines here on the same line just to save some space. And let me do that now. So I want to check if the event type is key down and the event key is case space. And if that is the case, I want to get my game active and set this to true again. And well, let's try all of this now. That's kind of all we needed. So now our game stops, and now I press space, and okay, this kind of almost worked. That right now, our game goes straight back because our snail, if you can see it, is overlapping with the player. So now it stopped, and now we can play again, and I can jump over the snail. This is actually working really well. But now I collide it again, and now we go to the game over state. But the problem here is, if I start the game again, our player is still overlapping with the snail, and hence the game stops after 1 frame. So this is something we do have to work on. But at least in theory, for now, this is working. And actually, what we could be doing is we can set our snail rectangle dot left to something like 800, just to make it work for now. So now let's try this again. So now we go to game over, and now I can start again, and we have a proper working game. So at this point, we actually have a really working game, where you have a failed state, where you have a challenge. It's not a very good game, but well, it does work. So for the rest of this tutorial, it's basically all about making this more interesting and making our code better organized. But you really have all the basics you need to create basic games. So well done so far. So for the next part, let's start working on the score. And all I really want to display here is the amount of time the player managed to stay alive. So for this one, we have to figure out how to measure time. And for that, we are going to need a new method. And that one is called pygame.time.getTicks. And all this one is doing is it gives us the time since we started Pygame in milliseconds. And that is really all we are going to need to create our timer. Although the actual logic to implement all of this gets a little bit more complex. But we get to that when we get to that. So let's go into our code and let's have a look at this. So here I'm in the code, and right now we are creating our text right here. So right now we are only displaying my game, and it doesn't really do anything. And further down in the game, right here, we are putting that text on the surface. But obviously this doesn't really help us all that much. So we have to make a couple of updates here. And let me start by just commenting out all of this, because we are going to make some changes. And here's what we want to do. We want to continuously update our score, which means that in our game loop, we have to continuously create a new score surface and put that on the screen. So that every time we are creating a new frame, we are also creating some new text. And to keep our code a bit more organized, I'm going to put all of this into its own function. So here I'm back in the code, and I want to create a new function, and let's do it right at the top. And let's call this one display score. We are not going to need any arguments, so let's go straight into the body. And the first thing we are going to need is our current time. And that we're going to achieve with pygame.time.getTicks. And this is going to give our time in milliseconds. And let's actually for now just print it and see what's going to happen. And let me actually put it into its own variable so you can work with it a bit easier. Let's call it current time. So I just want to print my current time. And now if I go down, we are drawing all of our stuff in these 3 lines. So what I want to do with them is to just comment them out for now. And now let's run this. And now you can see that we have a time that continuously updates at least as long as our game is active. And that is our time. So we can see that our game roughly ended 2 seconds after it started. And that is information we can use very well. So let me close all of this and let me go back to the top. So that's the information that we want to use. And all we really have to do is to put this on a new surface and put that surface on the display surface. So let's create a new variable that I call score surface. And for this one, we are going to need our test font and render again. And in here for now, all I really want to display is our current time. Then I need the 2 other arguments, which is false for anti-aliasing. And then I'm going to need the color, which was 64, 64, and 64. So now we have a new surface. Now with that, we have to create a score rectangle. And this one is just going to be our score surface with get rect. And in here, the center is going to be 450. the same position we had earlier. And now the final step we have to go with is screen.blit, and we want our score surface and our score rectangle. And then I can get rid of our print statement, and we should be good to go, at least in the most basic sense. And we are getting an error, because this right now is an integer, and this function here wants to have a string. So we can approach this in a couple of ways. In my case, I'm going to put this into an f string. So that way it's going to be converted to a string anyway. And now let me run all of this, and you can see a score. And if I keep on running the game, this is still working. However, here's one problem. Right now, the game ended. But now if I restart it, the score has continued to increase, which obviously doesn't work too well. And here, it's really important to understand what getTix does. And what it does is it gives us the time since Pygame started, or more specifically, since we called pygame.init. But obviously in our current setup, this causes a problem, because we only check the current time. We don't really adjust this for restarting the game, which is what's causing the problem here. So how can we adjust for this? And well, the answer here is kind of simple. All we really have to do is when we are restarting the game, we are taking the time when the game is restarting. And then when we are calculating our score, we are always subtracting that beginning time from our actual score. And that way, we are always starting from 0 and going from there. So let's implement that. And the first thing I want to do is to create a new variable that I'm going to call start time. And by default, this one is going to be 0. And now, essentially what I want to do is when I'm getting this number, I want to subtract my start time from it. So I'm going to subtract my start time from it. Now, right now, this really isn't going to do much because we just subtract 0 from this number. But now what I can do, if I scroll down a bit, in this bit here, I am checking for keyboard input to restart the game. And what I want to do in here, once this is activated, I want to set my start time to pygame.time.getTix. And that, in the most basic sense, is all we needed. So let's try this now. So our game still works properly well. Now I failed, and let's try it again now. And again, we start from 0. It's very hard to see because our counter starts too fast, but it does work. And let's try it again. Let's restart, and this is still working pretty well. So this is actually working really well. Cool. And let me just go through what happens here. Now, every time we are looking for our current time, we are checking in this bit here our current time since the beginning of our game. So since this line here has run. However, from that number, we are going to subtract the start time, so when the current iteration of our game has started. So that way, every time the player starts the actual game part of our game, we are going to have a 0 for our score. And then we're adding towards that score, which is then giving us a proper scoring system. Now there's one more problem, that right now, if I run it again, I think the score adds up a bit too fast and it's very hard to read. So I don't really want that high of a number. I want this to look more like 1, 2, 3, and 4, and so on. And that could actually be a really good exercise for you. Try to change our current time in such a way that you get more manageable numbers. Now, for this exercise, I think it was very easy to overthink the problem, which is a common issue in programming. So let me explain my approach. Essentially, this pygame.getTix gives us the milliseconds. So if we are at second 1, we would have a number of 1000. Now, this number I want to get to look like a 1. And really, all we have to do for that is to subtract this thing by 1000. And that literally is all we had to do in here. So all I want to do is to subtract this number by 1000. And let's put it into brackets, just to be a bit more clear. And what you can also do to avoid floating point numbers is to set this to an integer. So this way, this number here would always become a 0 or 1 or 2. And that is then the number we want to go for. Now there's one important thing you have to be aware of. That let me copy it. That right now, when we set our start time, this has to look the same. Actually, let me demonstrate what happens if we don't do it. So let me run the game now. We get 0, 1, and this is working really well. But now I failed. Let's start again. And now we get negative 5,000. So this is, well, kind of weird. And the reason for it is that this number here returns numbers in the thousands. This one here returns numbers from 0 to 10, basically. So that's something to keep in mind. But all right, so if I add this in here, now our game should be running pretty well. And the score is updating properly. And if our game ends and I start again, we start again with 0. So this is working quite well. And I think I have to increase the speed of the snails. That's a bit annoying. But okay, I'm going to work on that in a bit. There's one more thing I would like to add, and that I want to actually call this score, just to be a bit more clear. So now if I run this again, you can see score at the top. But it's up to you if you want to add it. Now, next up, I think the next big issue is that our game over screen looks kind of empty. So I want to add a couple of things to make it look a bit nicer, which is going to end up looking like this. That we have our player in the middle, we have the name of the game, and we have a short line at the end that tells the player how to restart the game. None of this is particularly fancy, and you should already be able to do most of this. Although there's one more important concept I would like to add in here, and that is how to transform surfaces. So for example, if you want to increase the size or rotate a surface, that's what transform is all about. And well, Pygame has a transform method. And if you look in the documentation, this part of Pygame has lots of different methods that you can use. For example, you can rotate something, you can scale something, you can flip something, you can do lots of different things with surfaces. Now, in my case, all I really want to do is to scale up our player to make it look a little bit nicer. But all of the transform methods work in basically the same way. So let's actually jump into this. So here I'm back in my code. And let me minimize our display score first, because we're not going to need it anymore. Now, next up, I want to create our game over screen in here. And all of this, our game so far, we can ignore because we're not going to work on it. So I am going to minimize all of this. And let me also minimize the event loop, so all of this is a bit easier to see. And first of all, I don't want this to be yellow anymore. Instead, I'm going to add a tuple that is 94, 129, and 162. And actually, just to test all of this, I'm going to set game active to false when we start our game. So that way we go straight to the game over screen. So let's run this. And now you can see a much nicer color. And again, if I press space, our game starts as always. So this one is working pretty well. Cool. And I guess with that, we can add the player in the middle of the screen. And for that, I first want to import our player. And let me do this right in the beginning. So I already have my player variables, and I want to create a new one here. Let's call this player stand. And all we have to do in here is pygame.image.load, as always. And there's one file that is just called player stand. And I am going to import this like all the other ones, and I'm going to convert alpha this as well. And now on the next line, I'm going to call this player stand a rectangle. And this one is just going to be player stand and get rect. And then the center is going to be right in the middle of our screen. So for 100 and 200. And let me actually add some comments. I think that's a bit easier to see. So let's call this intro screen. Now this is then what I want to display in the game over screen. So all we have to do on here is to use screen.blit and our player stand and our player stand rectangle. So now let's try this. And there we can see our little player. This works pretty well so far. So now I want to scale this one up. And how would I do that? And to scale something in Pygame, we actually have a couple of different methods. So if you open the documentation, we have scale, we have rotozoom, we have scale to X, and we have smooth scale. And they all essentially do the same thing, that they are changing the scale, but they do it in slightly different ways. And the result is going to look different depending on what method you are using. But for now, let's keep things simple. So I just want to use pygame.transform.scale, the simplest one I would say. And if you open this one, it tells you to add at the very least 2 arguments, the surface you want to scale up, and then a new width and a new height, both inside of a tuple. And then this one is going to return a new surface. And then you can use this surface like any normal surface. So let's have a look at that. Now, when I import our player stand, I want to create a new player stand. And just for clarity, let's call this scaled. And really all I want to do in here is to get my Pygame, transform, and scale. And now I am going to need a tuple with my width and my height. And unfortunately here right now, I have no idea about the dimensions of our player. So let's go with random numbers. Let's say for the width, I want to go with 200. And for the height, I want to go with 400. And well, now for our player stand rect, we also have to update this. But all we have to do is to get a new variable. So now I am simply updating this line here to get a rectangle around this new scaled surface instead of our player stand. And besides that, I also have to update the player stand down here to have this scaled one in there. So let's do that as well. So we want player stand scaled, and now this should already be working. So let's try it. And there you can see our player is very obviously scaled up. Really doesn't look all that good. So let's close this one. But this would be one approach with scale, although not a very good one and not the one I would recommend to use. However, before we are learning a better way to scale something, there's one more update I want to make. Because right now, this here doesn't feel like good code, because we are creating more variables than we really need to. So let me update this slightly before we get into the proper bit. And really all we have to do is to get rid of this scaled. And then again, we want to get rid of this scaled as well, and this scaled at the bottom here. And well, that's all we have to do. So let me go through what happens here. That's kind of important to understand. We are starting, number one, by importing this image. Now on the next step, so this number 2 here, we are taking the image and then updating it with this pygame.transform.scale. And this one is returning a new surface. And we're using that new surface to override the initial surface. And that's perfectly fine to do. That you take one surface, you scale it, and then you assign it to the variable that you originally used. And then we are creating the rectangle in step number 3. And then in step number 4, you are drawing all of this. So I hope that makes sense. And this is something you see fairly often. And also what you see fairly often is that you could just take all of this and paste it directly into the scale method. And if I run this, this would also still work. Although the downside of that is you would get one very long line that I think would be quite hard to read. So I'm not going to do that. And I think this is a fairly good middle ground between readability and efficiency of code. So I'm going to go with that one. However, the problem now is that this scaling just doesn't look very good because it distorts the image a lot. And there are 2 methods that would be better here. The first one is called scale to X. And this one is a really simple scale method. All it does is it takes a surface and makes it twice as large. And this one works by just calling scale to X. And this one needs only one argument, and that's the surface you want to scale. So now let's have a look at this. And now we can see a much better player. But there's one more method that I do want to show you. And that is called rotozoom. And rotozoom is a more complex method because it does 3 different things that you have to be aware of. Number 1, it rotates a surface. Number 2, it scales a surface. And number 3, it filters a surface. And the filter here is intended to make the resulting surface a bit smoother, so to make it look a bit better in some instances. And to call rotozoom, we are going to need 3 different arguments. We need the surface, the rotation, and the scale. So let me update this to roto zoom. We are still going to need our player stand. For angle for now, I'm going to go with 0. And then for the scaling, let's go with 2. And that literally is all we needed. So let's run this. And now we can see a surface that looks very similar. Although, if I compare these two images side by side, you can tell some very slight differences. And this is because of the filtering. And I actually think this rotozoom looks the best. So I am going to stick with this one. And actually what you can also do with rotozoom, you can change the angle. So if I change this to, for example, 90, we would also get a rotated surface. So this is a very easy way to both scale and rotate something, and still have the resulting surface look quite good. But I don't want to rotate it. So this one is perfectly fine by itself. So, alright, with that, we have learned about the basics of influencing a surface. Now, next up, we do have to add a couple of lines of text. So we do have to add the name of the game, a score, and the instructions to start the game. And this could actually be a really good exercise for you, that try to implement all of this yourself and see how far you get. But at this point, you know all the tools to make this work. So here we are back in the code, and I am going to go to our intro screen. And in here, I just want to create a new variable called game name. And for this one, we need our test font.render again. And now we have to specify the name of our game. And I just called this one Pixel Runner. But, well, give it whatever name you want. Then for anti-aliasing, I want false. And for the color, I go with 111, 196, and 169. So with that, we would have the surface of our text. Next up, we would need our game name rectangle. And this one is just going to be game name.getRect. And this I want to place at position 400 and 130. So in the middle of the screen, slightly to the top. And that is all we needed to get the name of the game. So now in our game over loop, we have to draw all of this. So we just need screen.split, then game name, and game name rectangle. And now let's see. And that is a little bit too far down. So let me go up again. And let's put this to, let's go with 80. And that is looking much better. All right, so with that, we have the name of the game in there. Everything else still works just the same. Cool. And now I'm going to add a second bit of text. And this one is going to pull double duty. If there's no score, it is just going to tell press space to run. However, if there is a score, it just shows the score. And to implement all of that, all we really need is an if statement that cycles between two different text surfaces. So let's start with the first text. And this I called game message. And this again, we need test font.render. And test font really isn't a good name, but I guess now we're stuck with it. And this is press space to run. Then I want false again. And now for the text color, I just want to copy the text we had above. So with that, we have our surface. And now I want my game message rectangle. And this one, again, is going to be game message dot get rect. And here, once more, I want to place the center. And now in here, I want to put it in the middle. And now for the Y position, let's go with 320. Let's see if that one is going to work. And, well, now again, we have to go with screen.split. I called this game message and game message rect. And let's see if this one is working. And it does not. Let's see what went wrong here. Oh, and the reason is that I have the wrong rectangle. So this should be game message rect. There we go. This is much better. And I think I could move this text slightly further down. So let's go with 340. Now let's run this again, and okay, tiny bit higher. So now the last thing that we have to do is to add some kind of if statement that we only show the text if there's no score, and if there is a score, we don't want to show the game message, instead we want to show the score. And for that, we do have to make a couple of changes. So let me go through them one by one, and I think it's best to explain it first and then we get into it. So right now, we are keeping all of our score inside of the update score function, which works fine by itself, but we want to access the score to display it in our game over screen. So we have to get the current time variable inside of the update score function. And for that, we could either create a global variable or we could return the value. And both would be okay. I'm going to go with the return statement. But once we have that, all we have to do is to put this current time on its own surface and then display it. That's literally all we have to do. So let's go back in the code and let's have a look at this. So here I'm back in the code. And right now, the variable that we have to access is this current time here, because that effectively is our score. So how can we access this? We could either go with global current time to make it accessible everywhere, or what we could also do is after this function is run, we can return current time. And this is the one I'm going to go with because it's a bit more focused. So now that we have that, I can create another variable, let's call it score, and this by default is going to be 0. However, now every time our update or display score is going to run, this score is going to get the value of whatever is being returned by this display score, which is going to be our actual score. So this way we can access the value of our score basically anytime. So now what we have to do, in the game over screen, we have to turn this into a surface. And well, this is going to work in exactly the same way as before. So I create a new variable, let's call it score message. And this one, again, I want my test font.render. And in this case, I want to go with an f string that says your score. And then we put our actual score in there. Then again, we need false. And for the color, I am just going to copy the same one again. And then after that, you should know this by now really well. We want to turn this into a rectangle, or we want to put a rectangle around it rather. So I want score message.get rect, and for the center, I'm going to go with 400, 400, and 330. So now this is going to give us our score. And now this score, I only want to print when there actually is a score. So when we are starting the game, this isn't visible. However, as soon as we have a score, all of this is going to replace this game message here. And well, to achieve all of that, all we need is an if statement. So if our score is equal to 0, we know we don't have a score yet. And then I want to display my game message. And if that is not the case, so else, I want to go with screen.blit and score message rect. And well, let's try. So I can run the game. We can still see our basic setup. Now let me run it. Now we get a score of 2, and there we can see it. So now every time we have a score, we can see it. And this is looking really well then. So I can also jump over snail, or I can't, and now we get a score of 4. So this one is indeed working. Very nice. And let me just update them ever so slightly to put them on the same line because that feels better. Cool. So all right, with that, we have all the text that we are going to need. So with that, let's work on another really important topic to make the game look better, and that is to spawn different kinds of obstacles. So right now, we only ever have a snail, and I want to mix this up a tiny bit, that we have a chance to either get a snail or a fly. So the player has to make a choice between jumping or, well, not jumping. And this is going to be a really good opportunity to work on something a bit more complex to spawn our enemies. Because right now, this is a bit overly simplistic. That we don't really spawn multiple enemies, instead we have a snail, we keep on moving from the right to the left. And then we just place it back to the right. And the problem here is that we have very little control. For example, we don't have control how fast the snail is moving. And we also don't really have control over how often it's spawning. So it's always the same interval, which is kind of boring. And to update it, we are going to need one new concept, and that is a timer. So that we can tell Pygame to run a certain kind of code in certain time intervals. And this timer is going to be quite simple because all we really are going to do is to create a new user event that's triggered by Pygame. And so far, all of our user events were something the player is doing. But that doesn't necessarily have to be the case, because a user event could also be triggered by Pygame. And a timer is one of those instances, where we tell Pygame to trigger a user event at certain intervals, which is what a timer really is. And there are 3 steps to doing all of this. Number 1, we have to create a custom user event. Number 2, we have to tell Pygame to trigger this user event at a certain interval. And then number 3, we have to add code in our event loop to do something when this event is being triggered. But that is all we needed. So let's actually implement this. So here I am back in the code, and let me add a new section with a comment. Let's call it timer. And in here, I want to have an obstacle timer. And all we need to create a custom user event is pygame.userEvent, all in uppercase letters. And here, one important thing is to add +1. The reason for it is that there are some events that are already reserved for Pygame itself. And to avoid a conflict with those, we always have to add +1 to each event we are going to add. And if you want to read more on that, there's quite a bit more in the documentation on this. But by itself, that's all we need here. So this would be step number 1, that we have created a custom user event. Now what we have to do is to trigger this event in certain intervals. And this happens with pygame.time.set_timer. And this is going to need 2 different arguments. Number 1, the event we want to trigger, and number 2, how often we want to trigger it in milliseconds. So in my case, I want to trigger my obstacle timer, and I want to trigger this every 900 milliseconds. So a bit shy of 1 second. But with that, we have a timer. So now in my event loop, I want to go all the way to the bottom. And here we are going to add a new event. So here, if event.type is equal to obstacle timer. And if that is the case, for now, let's just say print test. And now let's run it. And we can see test just about every second. So this one is already working pretty well. So with that, we have a timer. And I guess one thing we can add already here, that we only want to run this if our game is active. Because if it's not active, we don't have to spawn an enemy. So now let's try this again. Now we can't see anything, and if I run the game, we can see test every just about 1 second. Cool. So now we have a timer. But how can we use that timer to work with our obstacles? And well, here we have to make quite a few changes. So let me explain this first, and then we are going to implement it. But before that, let me go down a tiny bit. I want to get rid of this snail movement we had so far, because this one is not going to be needed anymore. So let's talk about how all of this is going to work. Now, first of all, we have to create a list that is going to contain all the rectangles of the obstacles. And every time our timer triggers, we are going to add a new rectangle into this list. And then on every single cycle of our game loop, we are going to move every single rectangle inside of that list a little bit further left. And if any of these rectangles goes too far to the left, we are going to delete it. And that way we can continuously create new enemies and move them to the left. And if they get too far to the left, we just make them disappear. So ultimately a fairly simple idea. So let's implement it. So here I'm back in the code. And right now we have all of our enemies in here. Or well, our one enemy right now. And let me add a section here as well. Let's call it obstacles, just to keep the code a bit more organized. And all I want to do in here is to get an obstacle rect list. And right now, this is just going to be an empty list. And now when we go to our timer, so down here, all I want to do is to get this obstacle rect list and append something new. And what I want to append is the rectangle, and this we already have. So this is going to be this rectangle here. So I can just copy it and paste it in here. Although we have to make one update, that right now this 600 needs to be higher, so that the snail is outside of the screen. And I want to have a value between 900 and 1100. And for that, we are going to need a random number. So let's import one. So at the top, I want from random import rand int. And this is just going to give us a random integer between two boundaries. And that is exactly what I needed. So now in here, all I want is to get my rand int, and this is supposed to be between 900 and 1100. So that way the snail is going to be spawned slightly to the right of the screen, and then we are moving it further to the left. So this is then going to give us our list, but obviously right now nothing is going to move. So to fix that, we have to create a function that takes care of all of that. And well, let me put it somewhere in our game active loop, and let's put it right after the player. So let's call it here, obstacle movement. It doesn't really matter where you put it, just wherever makes the most sense to you. And in here, I want to create a new function that is called obstacle movement. And in here, I want to add one argument, and that is the obstacle rect list. So we know exactly what we are working with. And well, let's create this function. So at the top of the code, I want to create obstacle underscore movement. And in there, we need an obstacle list. And now we have to work with this list. However, we first have to check if there's something in the list in the first place. And that we can just do if obstacle list. So this here is going to work because Python, if it finds an empty list, is going to evaluate that to false. So if our list is empty, this if statement is not going to run. But if it is going to run, we want to cycle through all of our rectangles inside of that list. So let's call it for obstacle rect in obstacle list. And then we want to move with every single of these obstacles. So obstacle rect, let's call it .x minus equal. And now we have to define a certain kind of speed. Let's say I want to go with 5. And that way, every single obstacle would be moved to the left by a tiny bit on every cycle of our game loop. So this is exactly what we needed. But right now, obviously, you can't see any of this. So this is something I also want to put right inside of here. Although you could also place it in its separate function. But in my case, I'm going to be a little bit lazy. But all I want to do in here is screen.blit. And for now, I just want to get my snail surface and then go with my obstacle rect. So that way we are moving our rectangle and drawing the surface in the same position, all in one go. But right now we have a little bit of a problem. That right now, all the stuff inside of this function here is going to be a local variable. And we want to make sure that we are targeting the global scope. And really, all we have to do to fix that is after we have done all of this, we are returning a new list. So the list we just created. So return obstacle list. And then in our game loop, when we do all of this here, I want to get my obstacle rect list and overwrite it. So let me explain what happens here. We first run this function here. And this is going to take our obstacle rect list and move every single rectangle inside of it a bit further to the left. And after that's finished, we are going to take this new list and overwrite the previous list. And that way we can continuously update our list and not worry about scope in too much detail. Right, so let's try all of this. And we are getting an error. And the reason for it is that Python told us that non-type has no attribute append. And you might already be able to figure out what went wrong here. And let me explain. Basically, if we run this, in the beginning, there's nothing inside of this obstacle list because our timer hasn't triggered yet. And as a consequence, this entire thing is going to return none. And none doesn't have the append method. So what we have to do, if there's nothing inside of this list, we have to else return an empty list. That's not an empty list, that's one. And that way our append method should still work. So now let's try this. And let me run this. And now we can see our snails. Obviously, they're all way too fast right now. Oh, and the collision doesn't work anyway. But now you can already tell that some of these snails move slightly differently because we have changed the starting position. So cool, this is already working. And I guess what we can do is that this 900 is probably a bit low. Let's go with 1400. Let's try this now. And let's see. Potentially still a little bit fast, but I think this is kind of workable. Okay, let's go with 1500. So with that, we have a slightly more robust system to work with our obstacles. But there are a couple of problems with this. And let me go through them one by one. Number one, the one problem we have already seen is that our collisions do not work anymore. So that's one thing we have to work on. Number two is right now, when our obstacle leaves the screen, we don't delete it. So we are going to end up with a longer and longer obstacle rect list. Something we really want to avoid because it would eventually slow down our game. And number three is we only have one type of enemy. So that's also something we have to work on. So let's start with number two, that we want to delete a rectangle if the rectangle goes too far to the left. And this we can do inside of our function. So inside of this function, we want to check if any of these rectangles is going too far to the left. So if this number here goes to, let's say, lower than -100. And if that's the case, we want to kill it. And all of that we can achieve fairly easily with list comprehension. So what I want to do is to get my obstacle list and assign it a new list already. And this list comprehension is going to check all of our rectangles and then see if they're too far to the left. So all we have to do in here is to go obstacle for obstacle in obstacle list. So this right now would only copy the existing list, so it wouldn't do all that much. However, what we can do now is we only want to copy an item if obstacle dot x is greater than 0. So that way we are only going to copy an existing item in the list if x is greater than 0. So that way we are only going to copy every single item of the list if the condition is true that the x attribute is greater than 0. So if the obstacle is on the screen. And if that is not the case, we are not going to copy the item and the item is going to disappear. And actually, let me go with -100. So we know that the obstacle is off the screen for sure. So this would already be the first problem we had to target, that we wanted to delete the rectangles if they leave the screen. So with that, let's go to the next point, that right now we only have one type of obstacle, which really isn't looking all that good. So instead, I want to have two different kinds of obstacle. And if you check out the folder, there are two different types. We have a snail and a fly. And I want to randomly spawn either a snail or a fly. And this isn't very difficult to achieve, but it does need a couple of steps to work through it. So let me explain it while I implement it. I think that is going to be the best way to approach this. So, all right, let me minimize the function. We are not going to need it for a bit. And instead, in my rectangles, I want to import a new variable. And let's call this fly_surface. And this is just going to be pygame.image.load. And the path towards this fly is going to be graphics.fly.fly1. Again, we have several images to get an animation. We are going to cover that very soon. But next up, I need convert alpha, and that is all we needed. Oh, and actually I just realized this snail rectangle we don't need anymore. So, all right, now we have our fly surface. And now we have to add this to our obstacle rect list. So right now, we always add the fly towards this. And here we want to randomly assign either the snail or the fly. However, there is going to be a problem, that the fly cannot be on the same Y position. So while the snail is on position 300, the fly has to be higher up because it's, well, flying. So we can't just add a random statement in here, but we can overcome this fairly easily, because all we have to do is to run an if statement that randomly triggers either true or false. And in my case, I'm going to use randin to do this. So here we have randin from 0 to 2. And this is going to give us a value that's either 0 or 1. And 0 would evaluate to false, and 1 would evaluate to true. So that way we have an if statement that randomly triggers true or false. And if it is true, I want to create a snail. And if it's not true, I want to create a fly. So let me just copy this entire line here. And now I want to get my fly surface. And the X position for that is still perfectly fine. But what I want to change is the Y position, because this one has to be high up. And in my case, I went with 210. So this way it would be slightly higher up. And now let's actually run this and see what's going to happen. It's not going to work perfectly just yet. Oh, and we're getting an error because this snail rect.left shouldn't be in there anymore. Now let's try this again. And we are getting another error somewhere down here. Oh, but we have the collision. So this one should also go because we don't need it anymore. And I hope now it's working. There we go. So now we can see a snail. We can see another snail. And now we can see a flying snail. I guess that also kind of works. So the problem here now is that we always draw the surface of the snail on top of the screen. And that would be a problem. So let me go to the part in the code in our function that right now it doesn't really check in our function if we are drawing a fly or a snail. We are always drawing our snail. And this is something that we have to change. So we have to figure out in this function if the obstacle rectangle is for a fly or for a snail. And the problem here is that the rectangle by itself has no information if it belongs to a snail or to a fly. It is literally just a rectangle with a size and a position. But that information we can use, because we know that the bottom of the snail is at position 300 and the bottom of the fly is at position 210. So really, all we are going to do in here is if the bottom of the rectangle is at position 300, we are going to draw a snail, and if that is not the case, we are going to draw a fly. And that way, we are going to draw only the surface that's appropriate. So let me cut this out here for now. And I want to get an if statement. That if obstacle rect.bottom is equal to 300, and if that is the case, I want to draw my snail. And if that is not the case, I want to draw my fly surface. And I guess again, I can put them all on one line. That tends to make it look a bit cleaner. And now let's try all of this again. Now we get a snail, and now we get a fly. Cool. So this is working pretty well. Oh yeah, I don't actually have to jump. It still works just fine. And we are getting a lot of snails, but we do get the odd fly eventually. Cool. So let me remove a bit of the white space here. And now we can close our function and never think about it again. So with that, we have different kinds of obstacles. Now, the final thing I want to work on is a collision between the obstacles and the player. And this I want to put in a whole new function, because that I think is going to make the most sense. But really, all that we are going to do in here is we're going to check the player and the obstacle rect list. And if the player is colliding with any of the rectangles inside of that obstacle rect list, then we want to end our game. And that is going to work in a very similar way compared to the obstacle movement function. That we are just going to use a for loop to get every single rectangle inside of the list, and then on every single rectangle, we are going to call collide rect. So let me start by creating a new function. So let's call this collisions. I guess that kind of works. And in here, I want to have two arguments. First one is the player, and then I want to have the obstacles. And in here, again, I first want to check if there are obstacles in the first place. So if obstacles. Very similar compared to what we have done earlier. So let me actually open both functions. So right now, this one here is pretty much the same thing we have done up here. Now, next up, I want to cycle through every single rectangle inside of this list. So for obstacle underscore rect in obstacles. And now I want to check if any of these obstacles is colliding with the player. So if player.collide rect with the obstacle rectangle. And if that is the case, I want to do a certain thing. And now we have to figure out what certain thing I want to do. And here, let me explain the problem. That right now, we have all of our code inside of this function in the local scope. So all of this here is the local scope. But the problem with that is that let me go down a tiny bit, that here again, we have our global scope. And the problem is that this game active controls if our game is active or false. And this game active is in the global scope. So we have to work out how to get from the local scope to the global scope. And well, here again, I'm just going to use a return statement. So I'm just going to return false. So as soon as our player collides with any of the rectangles, this value is going to return false. And all of this here runs without doing anything. Then we want to return true. And now all we have to do is to either assign this return false or return true to gameActive.false to gameActive in our game loop. So all I have to do is to go down to my game loop. And in here, we still have our collisions. So let me put it below there. And there I want gameActive. And this is going to get collisions, this one. And here, the two arguments we are going to need is our player rectangle. And we are going to need our obstacle rect list. And that should be all we needed. So now let's run this. And let's see if this is working. And yeah, there we go. So now our game is going to end if we collide with any of the obstacles. And just to explain what happens here, that this collisions can either return true or false. If there's a collision with an obstacle, it's going to return false. So this game active here is going to become false. And we are going to the else statement because this game active all the way at the top is not true anymore. However, if that is not the case and no collision triggers, this collisions here is going to return true. So this game active stays true and we just keep on going back to game active. So that way we have a proper collision mechanic. However, now we have one more problem. And let me run the game again. And let me just collide with one of the snails. And now if we run the game again, we still have the snail in the same place. So this is crashing our game immediately. To account for that, when our game is over, I want to empty our obstacle rect list. And well, all we need is to get our obstacle rect list and clear it. So that way we are removing every single item inside of it. And now let's try this again. And now we crashed. And now let's rerun the game. And now the game restarts properly. So this is working quite well. Cool. And actually, while we are in here, there are two more things I would like to add. Number one is I want to put my player rectangle at the bottom again. So .mid bottom is going to be 80 and 300, the same positions we have specified earlier. So that way the player is always going to start at the bottom of the screen. So for example, if we jumped into a fly at the end of the game and crashed because of that, our player would restart at the bottom. So that I think makes it look a bit better. And along with that, my player gravity should also be 0. So that way we start at the bottom and don't fall any further. It just makes the game a little bit cleaner. So, all right, with that, we have made pretty good progress. That now our game has multiple types of obstacles and everything else is still working just the same. Cool. Now with that, we can start addressing something slightly more complex. And that is to animate the fly, the player, and the snail. So that we don't have a static image, instead we have an animated image that looks significantly better. However, to achieve that, we are going to need a couple of different things. But in the most basic sense, we don't really do anything complicated. So let me explain what we are going to do. In the most basic sense, all we are going to do is to update the surface we are putting on the screen every few milliseconds. So for example, for the snail, sometimes we are drawing one image and sometimes we are drawing another image. And these images are very, very similar, but slightly different. And if you put them together fast enough, it looks like the snail is actually slithering, walking, moving, well, moving in an animated way, whatever you want to call it. And all we really have to figure out is how to update the surface every few milliseconds. And this can be done in a couple of different ways. As a matter of fact, our player animation and our obstacle animation works in different ways. For our player animation, we're going to create a random timer that updates on every single cycle of the game loop. And if that number becomes too large, we are going to change the image we are going to placing on the screen. And for our obstacles, we are going to create a new timer, so that we are changing every few milliseconds what kind of surface we are going to put on the rectangles. And that again was me talking way too much. Let's actually look at this in code. And let's start with the player. I think that's going to be the easier one. So here we are back in the code, and the first thing I have to do is to import a couple more images, because that's what we need for an animation. So if I scroll down a bit, in this part here, we have imported the player image so far, which is player walk 1. And what I want to do for now is to import more and put all of this into a list. So let me rename a couple of things. First of all, this isn't supposed to be player surf anymore. This is supposed to be player walk 1 or _1. Then I want to copy the entire thing and have player walk 2, and this is going to be the other image. So our player has walk 1 and walk 2. And if you play those two fast after each other, you have a walking animation. And those two surfaces I want to place into a list that I call player walk. And this is literally just a list with player walk 1 and player walk. And then besides that, I also want to import a file that I called player jump. And this is just going to be another surface. So let me copy the entire import line. This is just going to be jump.png. And with that, we have a surface that we want to display when our player is jumping, and when our player is walking, I want to alternate between these two different surfaces. But there's one more variable that we are going to need. And let me place it right under the player walk list. And I've called this one player index. And by default, this is going to be 0. And what this number is going to be is later on, we're going to use it to pick either this surface here or this surface here. And I have just realized that this should be player walk 1 and player walk 2. So basically, this player index is what we are going to change to pick either the first walk surface or the second walk surface. And we don't need that for player jump because we only have one surface for the jumping. And we can actually start using our player index right away, because right now we need a player surface to get the player rectangle. And this I just want to get back with player surf. And when we start the game, I just want to go with player walk. And from that, I want my player index, this one. So all this one right now is going to do, because it is 0, it is going to pick the first player walk surface. So right now, we haven't really accomplished anything. We just imported a couple more images that don't really do too much right now. So to actually make all of this work, we have to create a function. And let me go all the way to the top and create a new function here. And I've called this one player_animation. Spelled correctly really helps. And in here, we want to do a couple of things. We want to play walking animation if the player is on floor, or we want to display the jump surface when player is not on floor. So yeah, I hope that makes sense. And this player animation, I want to call in our main game loop. So all the way down here, let's say we can place it right before we blit the player surface. That kind of makes sense, I think. So now we have to create this function properly. And the first thing we have to do is to declare a couple of global variables because we want to work very much outside of this function. And the two variables that we need is player surface and player index. So we want to work with this player index here and this player surface. Those are the only two that we really have to influence from inside of the function. Okay, so with that, we first have to figure out if the player is on the floor or not, so that we can either display a jumping animation or a walking animation. And well, this is literally just an if-else statement. So if player rectangle.bottom is, let's say, smaller than 300, then I want to show the jump animation. And if that is not the case, I want to show the walk animation. And in here, the jump animation isn't actually animation, it's just the surface that we are displaying. So all we have to do here is to set our player surface to our player jump. I start to have a ton of variables. But this is literally all we have to do to get the jump animation. So if our player is not touching the floor or is above this Y position, we are just displaying the jump image. So that's literally it. But now for the walking animation, this gets a little bit more complicated. Because in here, we want to alternate between walk surface 1 and walk surface 2 at a fairly slow speed. And this I want to do with the player index, so the variable we declared earlier. So I want to first target that one, so player index. And I just, for now, just want to add not 1, but 0.1. So I want to slowly increase this number. And let me explain what I'm actually going to do. So let's say here we have our list with our two walk surfaces. So we have W1 and W2, short for walk 1 and walk 2. And by default, walk index is going to be 0. And let me use a different color for this actually. So by default, this walk index is going to be right here because it's 0. And then I don't want to jump straight to the next frame to walk 2 because that's going to be too fast. Instead, I want to increase walk index only by smaller increments. So that it takes a couple of frames to get to walk 2, which would be our index 1. This is why I'm only adding 0.1. But if I were to add 1 here, we would straight jump to the next walk cycle, but that would be too fast. Instead, I just want to go much slower. So I hope that makes sense. So with that, what I want to do now is to get my player surface again and just look at my player walk list. And from there, I want to take the index of the integer of player index. For the simple reason that we can only take the index with an integer. And this would already kind of work with the simple problem that we would very fast run out of this list. So this number here would go to 1, and then would go to 2, then would go to 3, and so on. But our list, so this player walk, only has two elements, 0 and 1. So what we want to do is after we reach 1, we want to go back to 0. So we have to add a bit more code to make sure that we get this border here that we don't cross. And this is fortunately very easy to achieve. All we need is an if statement between those two, that if our player index is greater or equal than the length of our player walk. And if that is the case, I want to set my player index back to 0. And that is literally all the logic we needed for this thing to work. And we are already calling the function, so let's actually try all of this. So it still works, and now we have a walking animation. And now if I jump, we have a jumping animation. So this is working really well. let me just go through this really quickly again. I think this needs a bit of explanation. So when we are starting our game, we are simply picking the first item here from our player walk animation. So we just get one of the walking animation. However, now in our game loop, further down here, before we blit the player, we are running our player animation. And if I look at this player animation looks at a couple of different things. First of all, it looks if the player is on the ground or not. So here, the first line or the first if statement, if the player is not on the ground or smaller than position 300, we want to change the player's surface, so the player image, to player jump. And this way we give the illusion that the player is jumping because we changed the image. But that's literally all that's happening here. However, if that is not the case, so if the player is on the floor, we want to show either walk 1 or walk 2. And to get these two surfaces, we use player index and increase this number very slowly. And if this number gets too large, so with this if statement here, we are setting it back to 0. And then we use that to animate the player. Although animate here literally just means we either pick walk 1 or walk 2. That's really all that's happening here. But alright, with that, we have our player animation. Cool. Now, next up, I want to animate all of the snails and all of the flies. And for this, we have a minor problem. That for the player, we only had to worry about a single surface. But we have lots of flies and snails on the screen. So animating all of those with this method would be a little bit annoying. However, we can approach this slightly differently. And what we're actually going to do is use a timer, both for the snails and for the flies. And essentially all we're going to do is we're going to create a timer that runs pretty fast. So it's going to trigger multiple times per second. And every time it triggers, we're going to change all of the surfaces for either the flies or the snails. Each of those have their own separate timer. And well, that's all we need. Let's actually have a look at this. So here I'm back in the code. And let me first import a couple more images. So for the snail, we have snail surf. Let's call this snail frame 1. And I want snail frame 2 as well. And this is literally just going to be snail 1 and snail 2. And then for the fly, we have the same thing. We have frame 1 and then we have frame 2. And it probably is going to make sense to separate them a bit more consistently. So this is going to be snail, and this is going to be fly. And in here, we have to do the same thing we did for the player. So we want a list with all the different frames. So it should be snail frame 1 and snail frame 2. And then the same for the fly. So fly frames is going to be a list with fly frame 1 and fly frame 2. And then both are also going to be needing an index. So let's call it snail frame index. And by default, this one is also going to be 0. So fly frame index going to be 0 as well. And then finally, we are going to need a default snail. So I called this one snail surface. And all we need here is our snail frames and then snail frame index. And then the same for the fly. So fly surface, and this is going to be our fly frames and fly frame index. So this is pretty much the same thing we did for the player. You can actually see it right below. And we could update each of these flies and snails in the same way we updated the player. Although this would be kind of annoying because we would have to do it for every single fly or snail on the screen. So that's not great. So instead, I'm going to create a couple more timers. So here we have our timers, and I want to create a couple more. So the first one is the snail animation timer, and I'm really bad at spelling animation, I realized. And this is going to be pygame.user_event +2. And then we need pygame.time.set timer. And here we have our snail animation timer. And for the snail, I went with, let's say 500. And now we need the same thing for the flies. So let me just copy all of this. And this is going to be our fly animation timer. It's going to be +3. And this one I've set to 200 because I think the fly should animate a bit faster than the snail. And now if I go down a bit, I just want to add a couple more if statements for updating these timers. And first of all, I want to check if our game is active because I only want to do this if the game is actually running. As a matter of fact, let's make some changes here. So I realized when we call our obstacle timer, we already check if game is active. So I just want to take this out here and check all the timers only if our game is active. So if game is active, then I want to run the obstacle timer. And I also want to check if event.type is equal to, let's start with the snail animation timer. Snail animation timer, this one. And all I have to do in here is to change our snail frame index either to 0 or to 1, depending on what we need for the animation. So if our snail frame index is 0, I want it to be 1, and if it's 1, I want it to be 0. And this is literally a very simple if statement. So if our snail frame index is equal to 0, then I want my snail frame index to be 1. And if that is not the case, then I want my snail frame index to be 0. And once I have all of this information, I want to get my snail surface again, and I want my snail frames, and pass in there my snail frame index. So this way, every time this timer is running, we are updating all of the surfaces for the snail. So once this timer is running, we are going to update all of the snail frames. And well, that's all we have to do. And now we have to do the very same thing for the fly. And I haven't done an exercise in quite a while. So let's do one now. That I want you guys to create a timer for the fly. And this is going to work in exactly the same way as we did for the snail. So if you want to code along, pause the video now and try this yourself. Alrighty, so let's copy all of our snail timer. And really all I have to do is to change snail to fly. So we have this fly, we have this fly. This is going to be a fly frame index. This is also going to be a fly frame index. Then this is a fly. And 2 more to go. We have fly here and we have fly here. And alrighty, so this is then all we needed for the fly animation timer. And now once we have that, let's try to run the code. And it's still running, that's a good sign. And now you can see animations for the snails, and I hope I get a fly soon. There we go. The flies are not animating. So let's have a look at those. And I have found the error. If you go up, right now, we call for both timers the snail animation timer. So we never actually call the fly animation timer. I just made a typo. But that's very easy to fix, fortunately, because this needs to be fly animation timer. And now let's try out of this again. And let's hope I get a fly fairly soon. And there we go. Now we have flies that also animate. And this is making the entire game look much more realistic and much more, well, animated. Cool. So with that, we have our animation, and this is another major step towards a good-looking game. So with that, we basically have a working game. But there are 2 more things we really want to add to this. Number 1 is music, and adding music in Pygame is super simple. The only reason I haven't done this is because I don't want to have music in the background every time I run the game. But you could add the entire music in a couple of lines of code. That's not the problem. However, there's one more topic I really want to cover that's fundamental to Pygame. But unfortunately, this is going to be quite a large topic. So this is going to be a larger section that is going to change our code quite substantially. And that is going to be the sprite class. And the sprite class you see all the time. In our code so far, we haven't really used any kind of class, but it might be really useful. For example, for our player, we have lots of different code snippets throughout our code to make our player work. But if we wanted to make changes to the player, it would be kind of annoying to do, because we constantly have to look around our code to find different things we want to work on. And our code is still very simple. So if you get a more complex game, this sort of setup would be a nightmare to maintain. And it would be a much better idea to have all of our player in one player class. So this would contain all the surfaces, the rectangle, the player input, all the animations, all of that stuff. Basically anything for the player is in one class. And Pygame is fully aware of that, and that's why the sprite class exists. Because all it really is a class that has a surface and a rectangle. And these are being drawn automatically in the right spot. And this makes it very easy to work with all of this. And in our code more specifically, I want to change a couple of things into its own separate class. Most importantly, our player is going to be its own class. However, I also want each fly and each snail to be its own sprite as well. And this would be the most common way to organize this sort of game. And, well, that is what we are going to implementing before we work on the music. And this is going to be a larger section. So, well, let's go through it slowly and I explain while I implement it. That's probably going to be the best. So, all right, here we are back in the code, and let me give some space right at the top. And I want to create a class, and let's call it player. And this player has to inherit from another class that's called pygame.sprite.sprite. And make sure you get the capitalization right. So this second sprite here has to be uppercase. And next up, we have to create an init method. So whenever this class is created, we want to do something. And this needs the usual self. And in here, the first line that's very easy to forget, we need super, and then the dunder init as well. So that we are initializing the sprite class right inside of this class as well, so we can access it. And this class is now going to need two attributes at the very minimum. One is called self.image and the other is self.rect. And the image is the surface that is going to be displayed by default. And the rect is, well, the rectangle to figure out where it's going to go. So we need self.image and self.rect. So in here, what you could be doing, for example, is use pygame.image.load and load, for example, our player walk1. And we still need to convert the alpha of it. And then for the self.rectangle, we could get our self.image and then get rect again. And in here, let me for now just place the mid bottom at position, let's go with 200 and 300. For now, I just want to place it somewhere so I can show you what's going to happen. So now we have an image and we have a rectangle. So what we could do now, let me scroll down a tiny bit and let me create our player is equal to player. So that way we're creating an instance of this class. However, if we're going to run the code now, oh, and I'm getting an error, this needs to be called. So now let's try it again. And now, if we run the code, we can't see anything. But the game, well, still works perfectly fine. So nothing is going wrong. So why can't we see this class here? And the reason why we can't see it is that Pygame doesn't draw sprites automatically. For the simple reason that a sprite is basically just a surface and a rectangle combined. But we also can't use screen.blit because that isn't going to work with a sprite. Instead, we have to do it differently. Instead, what we have to do is take all of our sprites and place them inside of a group. And then this group can do two different things. It can, one, draw all of the sprites inside of it, and it can also update all of these sprites, which is going to be really useful for us later on. And Pygame has two different kinds of groups. Number one is a regular group, and this one can contain multiple kinds of sprites. And this would be perfect for our flies and our snails, because they can all be in one big group and they are not going to interact with each other. However, for the player, it's not really going to work, because the player is supposed to be in its own group and self-contained. And for that, Pygame has a different kind of group, and that's called group single, which is a group for a single sprite. It's kind of weird, but well, it is what it is. So our player is going to be in single group, and all the other sprites will go in the normal group. And the major reason why I put them into different groups is when we are checking for the collision, we need to have them in different groups. That's really important. But that's going to come later. For now, let me first get rid of this player here. And instead, I want to, for my player, create pygame.sprite.group single. And into this group, so player, I want to add an instance of my player. And this way, we are going to have a group that's going to contain a sprite, and this sprite is going to contain all of this stuff here. And that way, we are able to access it. So now, if I run the code, we still can't see the player. However, now, if I go to my code all the way down in our game loop, our game is getting quite long. Here we have the player. Now I want to get my player. And on this, I can call the draw method. And in here, I have to specify one argument, and that's the surface I want to draw on. So in this case, screen. So now we can see our actual player. And well, this is going to be there forever. It doesn't do anything right now, but well, it's going to do very soon. So this way, once you have a bit of setup, you can add all of your code for the player in here, and then just add this to a group, and then call the group later in the code down here. And this is going to clean up our code considerably. However, we will have to recreate the entire player inside of this class. So this is going to be a slightly longer thing. So let me go through it step by step. And the first thing I want to do is to get my player input. So player underscore input needs a self as before. And in here, we have to get our player input. And here, it's really useful what we learned like 2 hours ago, that we can get all of the keys being pressed by Pygame. So pygame.key.get_pressed. And this is then going to give us all the possible key inputs. And we can just go through them. So if keys pygame.k_space and self.rect.bottom is greater or equal than 300, then we want to jump. So self.gravity is going to be minus 20. So this is pretty much the same thing that we have seen a bit further down here, all of this. So this is just making the player jump. But now, obviously, we need a gravity for all of this. So we have to set self.gravity to 0 by default. And now, since we have gravity, we also have to apply it. So define, apply gravity. Again, we need self. And in here, I want to go with self.gravity is plus equal 1, and then self.rect.y. So here again, we are just picking the rectangle to move it, and we just apply the gravity towards it. So plus equal self.gravity. And this should be a dot. And then to make sure that our player isn't going to fall outside of the game, we need self.rect.bottom. If that is greater or equal than 300, so our floor, then I want self.rect.bottom is going to be equal to 300. And this is going to be, we have put all of this. That is essentially this line here. Or these lines rather. And we are essentially going to do the same thing. The only difference now is instead of player rect, we have self.rect. But that's literally the only difference that we really have to worry about. So with that, we have our gravity and our jump mechanic. However, now if I run the code, nothing's going to happen. For the simple reason that we don't call any of these methods. And you might be tempted here to go with, let me find it in the code. Here we have our player, and you might be tempted to do something like player.jump or something. But that would be the wrong way to go on about it. Instead, what we're going to do is use player.update. And this is what I mentioned earlier, that sprite groups in Pygame have two main functions. One is to draw all of the sprites, and the other one is to update all of the sprites. And well, this is what we are going to make use of here. So instead of calling each method individually, what we are going to do is inside of our player class, we are going to define an update method. It still needs self, but in here, we are going to run self.playerInput, not index, input, and we are going to run self.applyGravity. And if you now go down a little bit further, this play update here is going to call the update method inside of our player class. So that way, we are going to use that update method to run all of the other code. And no, let me go all the way to the top again. The code is getting quite extensive. So now if I run the code, this should be working. And I made a typo. This should be self. Now let's try it. And now we can see that we have two players that, well, work together. And this is looking kind of freaky. And here you can see quite well, there's a very slight delay. But in our case, this isn't going to matter too much. But if you use different methods of input, so in this case, this key.getPressed is going to make a very minor difference. So just be aware of that. But in our case, it really doesn't matter. So with that, we have most of the player. The one thing that's missing is the animation frames. And well, that is going to be the longest part. And the first thing that we need to do is to import all the images inside of this class. So let me go down a bit. And here we have all the frames that we want to import. And let me just copy them. And now when we call the init method, I still want to import all of these. So what I want to do in here, and I also want to keep my self.playerIndex, and I also need self.playerJump. So let me go through what's happening here. First of all, we're going to import these two frames and place both of them inside of the player walk frames. And this needs self because we want to access it outside of this init method. Then we have our self.playerIndex. This also needs to be available in the entire class. And we need our self.jump. So this is just the jump frames. So this is very similar compared to what we did earlier, mostly because I just copied all of it. And now when we are loading our self.image, I don't just want to have walk frame 1 for it. Instead, I want to add my self.playerWalk. And from there, I want my self.playerIndex. And this is going to give us right now the index 0. So we would be picking this surface here. So still, if we are running all of this, it is not going to make any noticeable difference. We still have the same setup. However, what we can do now is to declare another method. And this I called animation state. Couldn't think of a better name. And what we are going to do in here is we are essentially going to copy this player animation. However, now we don't need the global methods anymore because we can work with self. So let's work through this step by step. First of all, again, we want to check if the player is on the floor or in the air. So this is if self.rect.bottom is going to be smaller than 300. Then we want to do one thing. And if that's not the case, we want to do something else. And well, all we want to do in here is to go with self.image and self.playerJump, I think I called it. Yeah, this one, playerJump. And if that is not the case, I want to get my self.playerIndex and add 0.1 towards it. And then again, I'm going to need the if statement to check if this index is still inside of this list here. So if it is going to be 0 or 1. And well, for that I need self.playerIndex is greater or equal to the length of our self.playerWalk. And if that condition is true, I want to set my self.playerIndex back to 0. And then finally, self.image is going to be self.playerWalk. Then we want to take the index. This needs to be an integer and self.playerIndex. So all of this is essentially identical to what we have done down here. The only difference now is that we added self to all of the statements before. But in terms of basic logic, this is identical. So with that, we have our animation state. And all we have to do now is to call it. So self.animationState. And now let's try all of this again. And now we have two walking players, and they also jump together. So this is working pretty well. So this is basically covering the player. Now, what is missing is that we don't have any collisions with the flies or the snails. But for that, we first have to create the sprites for all of these. So, well, that's going to be the next big step. That I want to minimize this class and create another class. And this class I have called obstacle. And also it needs to inherit from pygame.sprite.sprite. And in here, again, we have to define an init method that needs self. And this time we also want to have another argument, and that's the type of obstacle. So if it is going to be a fly or a snail. And then on the first line of the init method, we need super and then init again. If you don't do that, Pygame is going to throw an error, and it's very easy to forget. And in here again, we are going to need a self.image and a self.rect. Those are always needed. You can't have a sprite class without these two. And in here, I want to run an if statement to import different kinds of images depending on what I get. So if this type is going to be snail, I only want to import this stuff here. And if it's a fly, I want to import all of this. So before I create my image, I want to run an if statement. That if my type is, let's say, fly, so this would look something like this. So we are still importing two different surfaces, and we place both of them inside of a list that are called frames. So this is still very similar compared to the player. But now we are also going to need another thing, and that is going to be the Y position, because the flies need to be higher than the snail. So in this case, let's go with 210. And this is the number, if you remember from a couple of hours ago, that we have specified here. So 300 or 210. And well, that is going to be the Y position for the fly. And now all I have to do is, if that is not the case, so if we don't type fly and type anything else, I want to have an else statement. And this is then going to do the exact same thing except for the snail. So it's going to look like this. And that way, when we create the obstacle, we can just type in what kind of obstacle we want. And finally, we are going to need self.animation_index, and that needs to be 0. And now we can create our image and our rectangle. So for the image, we need self.frames, and here we need self.animation_index. And then for rectangle, all we really need is self.image.get_rect, and then mid bottom is going to be random.randint. This was between 900 and 1100. And then the Y position. All we really do is to set a certain kind of type and then use that type to either import all of this or all of this. And this is just going to give us a list with our frames and a Y position. And then later on, we are going to use that list to get an image, and then we use that image to get a rectangle. That's really all that's happening here. Now we do need a couple of other things now. The first one is, let's call it the animation state again. It needs self as usual. And in here, I want to do basically the same thing I did for the player. And this could be a really good exercise for you guys. That I want you to pause the video and try to figure out the animation for both the flies and for the snails. So pause the video now and try to implement all of this yourself. Alrighty, let's do it together now. So first of all, I need to get my self.animationIndex. And now I just want to add plus equal, and let's say 0.1 again. Although what you could be doing is set this animation index to a different kind of speed depending if you get a fly or a snail. But in my case, I'm not going to care. And now I just want to get my self.animationIndex is greater or equal to the length of our self.frames. And if that is the case, I want to set my self.animationIndex back to 0. And then finally, my self.image is going to be my self.frames. Then I take the index of integer and self.animationIndex. And this is going to be pretty much the exact same logic we have seen a couple of times now. So if I compare to the player animation, we basically did this part here. And all right, with that, we have our animation state. Now again, we have to declare an update method that needs self. And in here, I want to call my self.animationState. So this would be giving us the basic animation for the fly or for the snail. And let me minimize a couple of things in here so it's a bit easier to see what we are doing. And all right, so now I have my obstacle class and I want to add it to a group. So let me go down and let me properly add my groups here. And this I just call obstacle group. And this needs to be pygame.sprite.group. However, now we couldn't just add each of the obstacles right away, because we only want to do that when the timer ticks. So this is going to happen if I go all the way down. That is going to happen in this part here, where earlier we just had an obstacle rec list and we appended stuff towards it. But I don't want to do that anymore, and instead I want to get my obstacle group, and in here I want to add one instance of my obstacle. And for now, let's just call it fly. And now let's try and see what happens. And we can't see anything. And the reason for that should make a lot of sense. So if I go all the way up again, when we are initiating our class, we are putting our fly at position 900 to 1100 and slightly above the ground. So it's outside of the screen and it doesn't move into the screen. So that really doesn't help us. And just to illustrate that it is working, let me place it somewhere between 100 and 200. And now if we run the code again, we still can't see it. And the reason for that also makes sense, because when I go all the way down, we are not drawing this group. So what we have to do is to get our obstacle group dot draw. And this needs to be on the screen. And now it should work for real. And there we go. Now we can see that whenever the timer ticks, we are getting another fly, which right now looks kind of strange, but we can work with this. So now let me get all the way back to the top and change this back to 900 to 1100. But now what we want to do is to move this fly a little bit to the left on every cycle of our game loop. And literally all we have to do to make that work is to get our rectangle again, so self.rect, and now we need to target one of the points. In my case, I went with X. And then we need to subtract a couple of pixels every single time our game updates. So let's go for now with 6. And that way, this entire sprite is going to be moved to the left. However, there's one thing we still have to do. Let me go all the way down. Right now, we are only drawing the sprite. We're not updating it. So we need obstacle group dot update. And now we should be seeing a ton of flies. And there we can see one and, well, quite a lot more. And, well, now the game becomes really hard. Well, it's basically unplayable at this point. But okay, we are going to clean this up in a little bit. So, okay. So with this, we have our class properly now. And there's only one more thing that I do want to do. That whenever our fly or our snail is moving outside of the screen, it should be destroyed. And how we handled this earlier, if I go down a tiny bit, we used this line here to remove any kind of rectangle that is too far to the left. But if we have a class, all of this is much easier to do, because all we have to do is to define another method that I'm going to call destroy and self. And in here, I want to look for self.rect.x. And if this is smaller or equal to -100, I want to run self.kill. And this self.kill is going to destroy this obstacle sprite. And then all we have to do is in our update method call self.destroy. So this way, whenever this sprite goes too far outside of the screen, it's going to destroy itself. And we don't have to worry about it at all anymore. Although you can't really see it in our game itself, so there's no point in running it. However, there's one thing that you are going to see that we are missing right now. And if I go down a little bit further, I can actually copy all of this out because we don't really want to look at it. So these were the earlier sprites that we looked at, and we don't need those anymore. And what I want to work on right now is that we are always spawning a fly. But I also want to spawn snails once in a while. Actually, I want to spawn mostly snails. So I have to figure out some kind of mechanic here to spawn mostly snails and sometimes a fly. And there are quite a few different ways to make this work. In my case, I went with a little bit of a hack, so let me explain. First of all, I imported, besides randint, also choice. And choice allows us to pick a random item from a list. That's all it does. So now that I have that, I can, when I pass in the fly, I can pass in choice. And this choice is going to pick from a couple of different items. And in this list, I have one fly, and then I have a couple more snails. Let's put 3 in there. So how this is going to work is whenever we are calling our obstacle, this choice method is going to pick one of these 4 items. And since we have our snail 3 times, there's a 75% chance to get a snail and a 25% chance to get a fly. And well, let's try all of this. So now we should only be seeing our sprites. And well, now our collision is broken. But we should be seeing a fly, and there we go. And now we can only see our sprites. And this is working pretty well. Cool. And now let me actually hide the earlier player we created. So all of this here we don't need anymore. And literally all we are going to need is these 4 lines. That's literally all we need. We also don't need our obstacle list anymore. And we also can comment out our game active. And I think if you followed along, this code might look very confusing. But the main problem right now is that we are both having a sprite setup and a functional setup. And this can get really confusing. But if you were to actually work on a code, you would only look at these 2 classes, which is much easier to organize. And the only reason why all of this became so complex is because, well, I went through every single step. But in an actual game, all of this could be deleted and you would only have the classes. But in my case, well, the code got quite long. But if you look at this here, all the stuff I commented out, you could just get rid of. And well, that would make our code significantly more readable. But all right, let me update the player. So all the way at the top, let me hide all of this. When I initiate the player, it is supposed to be at 80 pixels from the left. So now let's run this again. And now we have the same setup except with sprites. And well, the one thing missing now is that we don't have collisions. So that's the last thing we have to add in here. And this fortunately is also very easy to achieve because sprites have their own collision mechanics. And the most common one is called sprite collide. And what this one does is that it takes a sprite and it checks if this sprite is colliding with any other sprite in another group. And if that's the case, it's going to return a list with all the collision sprites, which is super useful. And this we can then work with in a function. And as a matter of fact, we already have our collision function. And let me open it. And what I want to do is to somewhat copy this. So let's call this collision sprites. And for this one, now we don't need any arguments. And really, all we want to do is to first check pygame.sprite.sprite collide. And in here, we are going to need 3 different arguments. We first need a sprite, then we need a group, and then we need a boolean. I'm going to explain that one in just a second. But first of all, we need a sprite. And in my case, I want to get my player. And here you have to be careful because this player is not a sprite. It is a group single that contains a sprite. So that can be quite confusing. So this player by itself would not be enough. However, we can access the sprite very easily. All we need is .sprite. And since this class only has a single sprite, this is quite workable. However, in a regular group, this sprite would not work. You could only get a list of all the sprites. You could not get an individual sprite. So this is why we have group single here. All right, but then for the group, this is much easier. All we need is our obstacle group. And now we have the group that we need. Now for this boolean here. What this effectively does is that if this sprite here is colliding with a sprite in this group, we can check if this sprite is going to be destroyed or not. And this is what the boolean here is for. So if you're going to set this to true, every time our snail will collide with the player, this snail will be deleted. And if we set this to false, this snail will not be deleted. And in my case, I want to go with false, but in our case, it really doesn't matter all that much. But all right, now this entire statement is going to return a list. And if it doesn't collide with anything, it's going to return an empty list. And that we can use an if statement. So if there's anything in this collision list, we want to run some code. And well, all we really want to do is to return false. And if that is not the case, I want to return true. And this is going to be very similar compared to our collision function. So, all right, now all I have to do, if I go down quite a bit by now, we have down here our collisions. I still have our game active variable. And now we want to check collision sprite. And well, with that, we should have our collisions back. So let's check if this is working. And there we go. It's still working. But now we have the same problem again. That if I run the game again, the snail is still in the same position. So, well, our game would crash right away. So whenever, let me go all the way up again. Whenever this collision sprite triggers, we want to delete all of the sprites inside of our obstacle group. And this is very easy to achieve, because all we need to do is to get the obstacle group and empty it. And now if I run all of this, this should be working pretty well. So now if I collide with a fly, the game stops, and now it starts again with no sprites in there. And well, this is working pretty well. Cool. So now we have our game working again. So with that, we have made quite some noticeable changes. And there's a ton of redundancy in our code now, which isn't great, but I hope you get the principle following along. I'm going to upload all of the code in the proper way for the class-based approach. That's going to help understand all of this, I think. But if you could follow along, I hope this makes sense. But all right, there's only one more topping left to do, and that's to add the sound. And this is going to be a super easy part. And well, the audio part is going to be really quick because there's only really 2 steps that are both really easy. We first have to import a sound, and then we have to play it at certain parts in our game. And all of that happens with the pygame.mixer module. And this really isn't all that complicated. So I think the best way to approach this is to jump straight into our code, and then let's do all of this. So specifically, I want to work with 2 sounds. One is the background music, and one is a jump sound. So here we are back in the code, and the first thing I want to do is to add the player jump sound. And for that, I am opening the player, and when we initiate this class, I want to also import the sound. And let's call this jump_sound. And now to import a sound, we need pygame.mixer.sound. And as always, make sure that the S is capitalized. That's really important. But now all you have to do is to add a path to what file you want to import. And in this case, we have audio/jump.mp3. And that's all we needed to import a sound. So that's the first step. And now we only want to play this sound when our player is jumping. And that happens in this player input, that whenever we play the button, we want to jump. So we could play this sound ideally in here, and that would make the most sense. So let's play it there. And to play the sound, literally all that we have to do is to get our self.jump sound and then add play. That is literally all we have to do. So now if I run the code, we can still see our game. That's a good start. And now you should be able to hear a jump sound. So it's really as simple as that. Now there's one problem with this, that I think this sound is kind of loud and annoying. So I want to make it less loud. And this we can also do very easily. All we need is to target our jump sound again, and then add set volume. And in here we choose a value between 0 and 1, with 1 being the full sound and 0 being the sound muted. And in my case, I went with 0.5. And now this should sound significantly better, but do play around with it. I guess whatever you think is perfect. So that's all we had to do for the jump sound. Now, next up, let me minimize all of this because we don't need it anymore. And next up, I want to have an actual game sound, and let me import it right when we initiate the game. And let's call this BG music for background music. And this could be a really good exercise for you. Try to import this music and play it once our game has started. So all I want to do is pygame.mixer.sound, and now the file that we are going for is this one, audio/music.wav. And that is the music that we want to play. And now we have to figure out two things. Number one is, where do we have to add the code to play this music? And number two is, how can we loop this music? So this track here is only a couple of minutes long. And once it's over, I want to restart it. So that's another thing we have to figure out. But first, let me change this to lowercase music, so it looks a bit more consistent. But all right, now I want to target my BG music again. And again, what I want to do is to play this music. And now, as soon as our game starts, we are going to play the music. So let's try this. And you should be able to hear it. You can play with the volume a bit, it's up to you. I am not going to worry too much. And now, if we want to loop this, all we have to add is one argument in here, and that is called loops. And in here, we can tell Pygame how often to loop this. So for example, if I were to add a 6 in here, we would loop this track 6 times. But in our case, we don't want to loop it a certain amount of times. Instead, we want to loop it forever. And for that, we need -1. And this is telling Pygame to play this sound forever. And once it's over, to just restart. And well, you can't really see this in the game, or hear it, but trust me, it does work. But well, now with that, we do have the entire game. And if you have gotten this far, you have basically learned all the fundamentals of Pygame. So at this stage, you should be able to approach most 2D games. Now, obviously, you do have to practice using all of these concepts, but this is essentially all the concepts you need to make them. So I hope that was helpful.